Today I'm going to show you how to make the best game ever, Temple Run, in Unity. So we're going to make an infinite amount of tiles that keeps on going. The way it's going to work is that we're going to spawn a number of straight tiles that go straight in the direction that we are currently going in. And then ever so often, we will spawn a turn tile. So these turn tiles, there's a couple of them, they're sideways, left, and right. And so the player controller will be able to turn at the specified turn intervals, as well as slide and jump to avoid obstacles. And so this goes on forever. We will infinitely spawn these tiles, and then we will delete the tiles behind us. And so after this, once we have hit a game over, which is either hit by hitting one of the obstacles or turning at the run signal. Right now I pressed D, which turns right. And since there was nothing to turn right on, we have a game over screen here. So this game over screen has a high score that's actually connected to a server. And this server runs on 8locker, which is the gracious sponsor of this video. Thank you very much. And so what we can do here is enter in a name. So we can enter Sam as an example, submit to leaderboard. And so our score will be updated with our username. And so this will have a list of the top 10 scores in the leaderboard. And this is actually connected to a server, so it will be online, which is pretty cool. Additionally, we will implement progress. So this is the main menu screen of this game. So we can change the skin of our character, and these actually unlock depending on your progress or experience points in the game. And we will also put this together in 8locker. So I've already unlocked all 3 of the skin colors, and these are loaded in dynamically with 8locker at runtime. And so here we can choose the skin that we want for our character. So let's say we want the red skin. So once we click on it, you'll see that down here, it successfully updated our player storage. So 8locker also lets you store key value pairs on their database. And so once we click on this, we keep track of the player's current skin. And this can be used for any kind of unlockable in your game. And you'll see that once we click start here, the player skin will change to red after some time. Now you'll know that there's a small delay in changing it to red. However, that's just how I designed the code, and that's easily fixable in your code base. So before we get started, I just want to thank 8locker, the sponsor of this video, which we will be using some of their services. And so 8locker is a super easy way to integrate a ton of features into your game without needing to do the heavy lifting. So for example, if we go to the features tab here, you'll see that they support a ton of features, which if you do it yourself could take a ton of time. So some of them include achievements, collectibles, crafting, which is coming soon, heroes and classes. So having different classes and defining their different attributes, defining what they can equip or store in their inventory. They also have inventory, which is really nice. Leaderboards, missions, progression. You can integrate DLCs into your game, have an in-game store, loot boxes, different currencies. You can implement easy login, player counts, and this works on Steam, Xbox, PlayStation, Switch, or mobile. So we have an empty project here where we will start. So first open up your project or empty project. I'm using version 2021.3. For some reason this is so tiny I can't even see the version number. But first we want to install some packages that we'll need. So for that you want to go to Window, Package Manager. Up here go to Unity Registry. And then we can search up here, or you can scroll down in the packages. First, we'll want Cinemachine install on the bottom right. And so for some reason, if you get this error that you're not able to add packages, you're going to want to sign out and sign in to Unity again from the Unity Hub. So right here, you can go to Unity Hub and click the icon and sign out. Then you can click again to sign in, which this will pop up, and you'll want to open Unity Hub. And you can just go through that process. So once that is done, we'll want to install the input system as well, which is how we will manage input. If you're new to the input system, I have a ton of videos on my channel that I recommend checking out. So we can type here input system, and we can install the latest version and click yes here to restart the editor. And this is for the input system changes to take effect. Hope you like my background here. Now we just wait 10 years for this to load up. And the last package for now that we will need is ProBuilder. ProBuilder. And this allows you to build different meshes within Unity pretty easily without needing to use Blender or a 3D modeling software, which this is great for testing out different layouts on your scene. And so we won't really be diving into ProBuilder, I'll be giving you some prefabs already that I made because making those prefabs took a long time, and I rather just give it to you so we can focus on the more important part, which is the actual mechanic of infinitely spawning the tiles. All right, so we can close out of this, and then in the description below and in the pinned comment, there will be a link for the prefabs that I will provide. So go ahead and download that. So once you downloaded that from the description, you can just drag and drop this Temple Run Prefab Unity package onto your scene and then click import. So in this prefab folder, if you double click these prefabs, you'll see that these are the different tiles that we'll be using. And these are made with ProBuilder. So as a very little introduction to ProBuilder, you can go to Tools, ProBuilder window, create a new shape, and then it'll ask you what shape you want to create. So if we can make this donut here, and so once we click on the scene, we can kind of specify how large we want the donut to be, and then you can specify the 3D axis by moving your mouse up and down. And so you'll see we create this nice little donut, and you can increase the radius, the number of rows that it has, the columns, if you want it to be smooth or not. And if you want to edit this, you can click on it, and then here are the different options that you can edit. So if you want to edit a face, you can click this button here and select the face you want to edit. And then it's the same controls as in Unity. You can extend it upwards or downwards. If you press E, you can rotate it. If you press R, you can scale it. And these are the edges and these are the vertices. So you can change any one of those properties with ProBuilder, which is really cool. But anyways, back to the main topic. We have these tiles here. And so these are ProBuilder tiles. And you can extend these if you'd like by clicking Open ProBuilder, clicking Face Selection, clicking the face you want, W, and then you can extend it however you like, but I don't recommend extending it right now. And so the main thing here is that we have this main tile has a box collider. So then I added another object with ProBuilder to add a little entryway into this turn tile, which is this first child of the left game object. Then we have this turn threshold, which is just a box collider. And this will let us know once the player has entered this box collider, if they press the key to turn, then they can turn. So the player has to press the turn key within this box collider in order to turn to the left. So this is just an easy way to check if they're in the correct location to turn. And then the pivot is just an easy way for us to tell where the position of this game object is, and we'll explore more of this in the future. So if we go to the right tile, it is the same thing but turning right. And then sideways, it is the same thing, but you can turn left or right. And so how do we know whether we have a left, right, or sideways tile? Well, we have this tile script, so you can right click and edit script. And yes, I trust the author of myself. So basically we have an enum of tile type with the different kinds of types of tiles. So straight, left, right, sideways. And so an enum is just a collection of something. So all of these are really integers. So if you hover over it, you'll see that this is 0, this is 1, this is 2, this is 3, kind of like a list. And then we give it whatever name we want. So usually the convention is capital letters, straight, left, right, and sideways. And so we have this collection of tile types. And then we have a tile, which this is what we attach to the game object, which has the tile type, as well as the pivot, which we drag it and drop it in. Here we see that we dragged this pivot into this tile. And so this is so that we can easily access these values from another script later on. And then I put this in a namespace so that we can group scripts together and access values between them more easily. So if we create another script now and we put it under the same namespace, we won't have to import this tile script in order to access the tile type, which is pretty neat. And so we'll go over that soon. So the last two things are the obstacles and the slide obstacles, and these are just what will be spawning into the scene. And you'll see this is an empty transform, and the actual cube is a child so that we can position it more freely in relation to its parent. And we'll be going over this soon. So enough about that boring talk, let's actually make something work. So let's create a script called tile spawner. So right click and create a new folder called scripts. I like to put an underscore before script so that it's always the first one in the assets folder. Then we can right click and create a C# script called tile spawner. And you can double click that. All right, so we can erase these two functions. We can also erase this using system.collections. We'll be using this one later on. And we can put it in the namespace Temple Run, or whatever you want to call it. All right, so the first thing we want to do is get a reference to the tiles that we want to spawn. So first we have our straight tile. So we can do a serialized field private game object starting tile. And the serialized field is so we can see this and drag the game object in the inspector while still having it be private so no other object can access it. Then we want a serialized field with a list of game objects of the other tiles, so of the turn tiles. We also want a list of the obstacles, so private list game object obstacles. Some other things we want to declare are a private integer of the tile start count. So I put this at 10. This is basically how many straight tiles will spawn at the beginning of the game, giving the player a little leeway to start. Usually you don't want to throw obstacles in their face immediately. Then we want to enter a range. So we'll be randomly spawning a certain amount of straight tiles. And we want a range for this. So we can do private int minimum straight tiles. I like to put this at 3. So this basically guarantees that there will at least be 3 tiles before another turn. And similarly, we want a maximum straight tiles so that the player doesn't go straight forever. Alrighty. Some other things that we need to declare are the current tile location. So private vector 3, current tile location, and we can just set that to vector 3.0. We also want the private vector 3 current tile direction. So this is the direction that we are currently moving in. So we can just set that to vector 3.forwards because we want to go forwards to start. We'll also want to keep track of the previous tile, and this will mostly be for turning. And once we turn, we need to determine where to place the next tile, and this will help us by getting a reference to the previous tile. We'll also want a list of game objects of all the current tiles on the scene. And we'll also want to keep track of the current obstacles on this scene. Alrighty, so now that we have all of that declared, now we can get into the juicy part of the code. So let's declare a start, private void start. Let's initialize these lists. So current tiles equals new list game object. And we can do the same for current obstacles equals new list game object. Now, before we actually start spawning the tiles, one small thing we want to do is that since we're going to be using Unity's random numbers, you'll notice that if you just use it normally, it's not really random. So you can see in this documentation, for example, the random number isn't really random, but produces the numbers in a preset sequence, and it basically jumps around this sequence in a random order. The point where you start is called the seed. And so if you don't set the seed, you'll notice that you start to get similar values over and over again. So we can set the seed by doing random.initState. And here you want to enter in a unique number. For now, what usually works is that you can use system.datetime.now.milliseconds. So this gives you the date right now in milliseconds. And so this kind of guarantees that this number will be pretty unique whenever this game is run. All right, so we want to start by spawning in our straight tiles to start. So we want to do a for loop. For int I equals 0, I is less than some X amount of tiles that we want to spawn. We can use a random number, or we can use our tile start count right here. Tile start count plus I, or I plus plus. So now here we want to spawn our tiles. So spawn the tile. And so we need to make this function. So let's just make it here. So private void spawn tile. And we want to actually input something. So we'll use this for both the straight and turn tiles. So we want to tell the function what kind of tile it's spawning. So we're going to be spawning the starting tile, and we're actually going to be passing in the tile component of it just to make our lives easier so we don't have to keep referencing the tile since we're going to be using it a lot. And then here we're going to put false because in our spawn tile function, first we will accept the tile, and then we will accept a boolean called spawn obstacle. So do we want to spawn an obstacle on this tile? No, we do not, because this is the first set of tiles that we're spawning for the player. And then after we spawn these straight tiles, we'll want to spawn a turn tile. So here we'll spawn a turn tile, which will just do that a little bit later. Let's just do the straight ones for now. All right, so we can spawn these tiles by doing gameObjects.instantiate. We can access the game object of this tile, tile.gameObject. We have to put the location where we want to spawn this tile, which we already have a current tile location. And then here we want to put the rotation that we want to spawn this object at. And we'll be going over this in a bit, but for now we can just put it at quaternion.identity. And so we want to equal this to our previous tile variable so that we can keep track of the previous tile. Then we can add this to the list of our current tiles, currentTiles.add previous tile. And then we can add in the offset where we want to spawn in the next tile. So we can do that by doing current tile location plus equals, and here we want to plus it by the size of our current tile in the correct direction. So what does that mean? So if you look at our straight tile here, this is the forward axis, you'll see that this is 10 units in length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 meters. And so we'll want to spawn the next one of these right here. 1, 2, 3, 4, 5. Because the transformed position is at the center of this. So we basically want to shift it 10 meters over to spawn the next one, so that the next one will be at the correct location facing the direction we are currently moving in. So we want to take into account the length of this tile along with the direction that we are moving in. So to do that, there's a handy little function that we can use, and it's called vector3.scale. So vector3.scale multiplies one vector by another element-wise, which is very important. So we want to get the size of our current tile, which we can do that by previous tile.getComponent render.bounds.size. So this returns the complete vector3 dimensions of our box. And then we want to multiply it element-wise by the current tile direction that we are going in. This current tile direction, out of the 3 values in the vector, only one of those values will not be 0, and that's the direction that we will be going in. For example, if we're going straight, the Z will be 1. If we're going to the right, the X will be 1, and everything else will be 0. So for example, if we're moving forwards in the Z axis, and this is the size of our tile, then we multiply it. 3 times 0 is 0, 4 times 0 is 0, 5 times 1 is 5, and it'll return a vector of 0, 0, 5. And so basically we'll add this onto the current tile location, and this will be the correct place of the next tile because it takes into account the direction that we're going in and the length that we want to add in. Alrighty, so we can exit out of that. Then in the main scene, we can right click and create an empty game object and call this the spawn manager. And then we can add in a component of type tile spawner, which is the script we just made. Next, we want to add in our starting tile, which you can click this little circle right next to that. Go to assets, and then you'll have a list of your prefabs. Just click the straight tile. Then you can expand these lists that we created, and you can add in the turn tiles, which we have 3 of right now. And for the obstacles, we have 2, and it'll populate that for you. Now for each one, you can add in from the circle, or you can drag and drop directly from here. So one cool thing that you can do is in the inspector, you can right click and lock this window so that when you click these values, this won't change. So you can click the left prefab, press Control, click right and sideways to select all of them, and then you can just drag them onto turn tiles. And you'll see that it added them on, but it kept the last 3. So actually, let's delete these. And for the obstacles, we can put that to 0. And then we can click on the obstacle, Control, click on the slide obstacle, drag that into the obstacles list, and it'll populate it. Awesome. So now we can unlock that from the inspector. And once we press play, you'll see that in the scene here, we can double click one of these. All the tiles are spawned in line. So you can see they are spawned correctly at the correct position, and they do not overlap, and they spawn all the way until the 10th tile. Pretty neat, right? Alrighty, and so now let's spawn in the turn tile. So right here, we can uncomment this out, and let's spawn in the first turn tile. So we want to randomly select a tile to turn. So we can actually make a new function called select random game object from list. And we're doing this so that we can easily pass in whatever list that we want. So we can pass in whatever list we want and select a random value from it. And here we want to return a type of game object. So as an extra measure, you can actually check if there's actually anything in the list. So list.count equals 0. If it equals 0, just return null. We're not returning anything. Else, let's select a random tile. So return from our list. Within this list, the index, we're going to select a random index, which you can do random.range from 0 to how many items there are on the list. So this selects a random value from 0 to 2 because it excludes this value, the random.range. So if we put in 3, it actually does a range from 0, 1, and 2, which is perfect because we only have 3 values. And it'll select a random element from this list. All right, so back in the spawn tile function, we can call this select random game object. We can pass in our list of turn tiles, and then we can put in false because we don't want to spawn an obstacle here. Then we want to get the component of type tile, and then we can just put in false here. Or instead of putting in false a bunch of times, you can equal this to be false. So this sets the default value of false so that we don't have to pass in false. It'll just be that as the default. All right, so now that we've done that, let's just make sure that everything's working properly. And we go to the scene view, you'll see that we have this straight tiles here, and then it spawns this left tile. However, you'll see that there's something wrong here. If you click this straight one, it's clashing in with the left, and this left isn't left, it's right. So the rotation of this object is incorrect. So we'll have to fix the rotation of this object to match the direction that we're going in. And you'll see that we can actually rotate it here, and we'll have to get it rotated 90 degrees on the y-axis for it to be correct. And so before we do that, I actually like to change the layout of Unity to tall. And then I like to put the game view to the bottom, just so we can see both screens at the same time more easily. And this will help for debugging and just make your life easier. All right, so now let's add in that rotation. So we want to rotate it in the direction that we are currently moving at. So to do that, we are going to use a quaternion, which is a way to represent a rotation within Unity. So we can say quaternion new tile rotation equals. And so what we want to do is that we want to look at the direction that we're currently moving at. And you can do that with quaternion.look rotation. You can look at the current direction. And then this is the axis that we want to rotate it around. So we want to rotate it around the y-axis so that it can look forwards in the direction that we are moving in. And so you'll see that if we do this, this actually won't work because we have to take into account our current rotation, which is very important because this will rotate it in the direction, but it won't take into account the current rotation of our tile. So we can do tile.gameObject.transform.rotation, and then we can multiply it by this rotation. And so now this rotation will be performed on our current tile rotation. And now in this previous tile where we instantiate it, we can replace the quaternion identity with our new tile rotation. And now if we minimize that, we can go back into the scene, press play, and you'll see that the orientation is correct. So now we have this tile, and then the next tile is the sideways tile. And if we press play again, or again, whenever it wants to give me a new tile, you'll see that the right tile is correctly pointing to the right, and it's not overlapping with the straight tiles. Awesome. Also, I recommend backing up your projects while you're working on these bigger projects, because if something happens to your computer and you lose your progress, that'll be sad. Okay, so that's cool and all, but let's actually make it infinitely generate, right? And then after that, we'll spawn in the obstacles. So we want it to generate a new tile set right when the player turns. Because since we don't know the exact direction that the player will be going in some instances, we don't want to compute and spawn tiles in a direction that they won't go in. This is mostly for the sideways tile where you can go left or right. If it's just the left or right tile, we obviously know in what direction the player will go in. But then again, the player can always run into the wall and lose before turning. So the easiest way is just to spawn it right when they turn, and it'll just make our lives much easier. So let's create a new function that will be called once the player turns. Now let's make this public because we want it to be accessible by the other scripts. And so we want to call this add new direction. And let's put in the direction that the player turned at, vector3 direction. So a couple things that we want to do is we want to set the current tile direction to the new direction to keep track of it. We want to delete the previous tiles because we won't need it anymore. And I actually don't recommend doing this because we'll be instantiating and deleting a lot of tiles and that takes up computation. So I actually recommend using an object pool, which I do have a video on. I won't be going over in this video because there's just a lot in this video already. So I definitely recommend looking into object pooling to better utilize your resources without having to instantiate and destroy the same object a million times. So we can just do a private void delete previous tiles. I misnamed it, forgot to put the S. And we can actually do this a little later. Let's focus on adding this new direction when we turn. So we want to set the next tile location depending on the direction the player is turning. So this is actually a little annoying because it just requires some weird math stuff. So I'm going to walk you through it. So we're going to use that vector3 scale function again so that we can multiply the direction we're moving in times the length so that we can just get the correct axis that we are moving in and the distance where we want to spawn the new tile. So let's just do vector3 tile placement scale, or there could probably be a better name for this, and we'll set that in a moment. Alrighty, so the left and the right tiles are the same size, but the sideways tile is a different size. So we'll have to do two different if conditions depending on if it's a sideways tile or it's a left or right tile. And luckily, we already have access to the previous tile, which is the turn tile because it's the most recent tile. So if we do here, if previous tile dot get component tile dot type equals tile type dot sideways, then we do something else. This is the left or right tiles. So let's do the sideways one to start off. So we do tile placement scale equals vector3 dot scale, and then we want to multiply the current length of this game object tile times the current tile direction. Now this is the tricky part here. So if we look into this sideways tile here, the pivot is right here in the center. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 20 in length. And we want to spawn the next straight tile 10 plus half the size of the straight tile. Because remember, the straight tile is 10. However, we don't want to spawn it 10 away. We want to spawn it 5 away so that the straight tile will be correctly positioned in this direction. So it's here 10 plus 5. So it's half of this sideways tile plus half of this straight tile. If we go back to our script, we can do that pretty easily. We can get the current tile, which is the sideways tile, previous tile dot get component render parentheses dot bounds dot size divided by 2 plus, and now we want half the size of the starting tile. However, if we access, for example, our starting tile here, this is a prefab, and a prefab isn't instantiated onto the scene, so we can't access the render component of a prefab that isn't instantiated on the screen. So what I did is that I put a box collider on it, and a box collider you can access even if an object isn't instantiated. So I want to multiply this bounds.size by the length of our tile. So I want to add in the length of our tile here. So we can do starting tile dot get component box collider dot size dot z divided by 2. The z is the direction I defined. That's forward on the straight tile. And you'll see that here we can't add in a vector3 and a float, unfortunately. So what I did is that I put this in parentheses, so the latter part, the starting tile, and I multiply it by vector3.1 times the size of this starting tile. So basically, if this is 5, this will create a vector3 of 5, 5, and 5 on all axes. So it'll create a vector3 like that. And it's not that we actually need all those values, because they will get cut off by this vector3.scale, which will multiply it only in the direction that we are moving. And now we can copy this and use it for the left or right tiles. The only difference here is since it's not sideways, we don't need to divide it in two. However, there is a little offset. So if we click on this left one here, you'll see that the pivot is placed 2 tiles away from the right. So we want to spawn the next tile 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus 5, 17 away. So if we get the box collider of this tile, it'll return this whole length. And we want to just subtract 2 from this, which are the edges. So back in the script, we can remove this divided by 2. I'm going to put this first part in parentheses, and then I'm going to subtract the size by 2. But once again, since we can't subtract the vector and the float element-wise, we have to put another parentheses and do vector 3.1 times 2. So all we're doing is basically determining where we should put the next tile. And now, once we determined our new tile placement, we can add that to the current tile location. So current tile location plus equals tile placement scale. And now we can spawn in the rest of the tiles. So we can spawn in straight tiles in the direction we're going in, and then another turn tile. So let's first put a number of current path length equals random.range, and we can do the range between the minimum amount of straight tiles and the maximum amount of straight tiles that we want to spawn. Then we can do a for loop int I equals 0. I is less than the current path length that we just did, plus I. Now we can call spawn tile function, and we can pass in the starting tile, which is a straight tile, get component tile. And now we can pass in true here because we want to spawn an obstacle. However, we probably don't want to spawn the obstacle right away once they turn. So here we can do a shorthand if else statement. So I equals 0. If I is 0, then false. We do not want to spawn an obstacle, else true. This is just a shorthand notation. If this is true, question mark, do this, else, semicolon, do this. All right, and then we want to add in the turn tile. So spawn a new tile and select a random turn tile from the list of turn tiles. Dot get component of type tile, and this is just to pass it into the function, and we do not want to spawn an obstacle here. Alrighty, so now let's test if this worked properly. So to test this out, let's go to the start function here and comment out this select random game object from list. So let's manually add in a turn tile so that we can see if everything is working properly. So let's do spawn tile. Now we need to select a tile. So we already have a list of our turn tiles up here. So we can do turn tiles and then index it by 0, let's say. And then we have to do dot get component of type tile. And then we do not want to spawn an obstacle, so we can just leave that blank. So just checking what that turn tile was in the first element, it's left. So we will always get a left turn tile in the first round. And so now since we can assume that the player is going to turn left, we can just call this function add new direction, and pass in the left. So vector3.left. All right, so if we go into Unity and press play, if we go into the scene view, this is spawned correctly. But if we go to the left tile here, you'll see that once we turn, the other tiles are spawned in the correct location, but they're a little bit shifted towards the positive Z axis. And this is because if you go back to the script, in this spawn tile function, you'll see that we're adding the current tile location plus equals the length of the straight tile. However, when we're turning, we don't want this to be added because we're going to be turning in a different direction. And this is going to shift our next tile over by the length of the previous tile. So we only want this to be executed if we're going straight, because if we're turning, you see in the add new direction function, this is already calculating where the next tile placement is going to be when we turn. So we don't need this to be calculated because we're already doing it in the add new direction function. And this is causing a shift in the tiles when we turn. So we can just add an if statement, if tile.type equals tile type.straight, then we can execute this function. Now you'll see that when we press play, and we go here to the scene view, everything works correctly. Awesome. And you'll see that if you continue to add more tiles, even over here, it'll work properly. It'll go straight and then it'll turn in the direction that you want, or in the direction the player's turning. Alrighty, so now when the player turns, they won't be able to see the previous tiles before them. So let's just delete them so that they're not taking space. And if for some reason our algorithm, the randomly chosen tiles, keeps going in a circle and we don't delete the previous tiles, we'll see them in the scene. Now, I don't necessarily recommend doing this. I recommend using an objects pool so you can avoid instantiating and destroying the same objects over and over again. And I have another video on that, which I recommend checking out and is in the description. But for simplicity of this video, since this video is already action-packed with a ton of content, we will just delete it. So we already have a list of the current tiles on our scene, which we declared here. Current tiles equals new list game object. And then in the spawn tile function, we add the tile that's instantiated to the current tiles list. So in this function, delete previous tiles that we previously declared, we can just do a while loop over the current tiles. So we can do while current tiles dot count does not equal 0. So while there are some items on this list, let's remove them. So you can do game object tile equals current tiles at 0, and this gets the first item in the list. And then you can do current tiles dot remove at, which removes a object in a list at a certain index, so we can remove the first one. So we're just getting a reference to the object in the list before removing it from the list. And now we can actually destroy that item that we referenced tile. And so this while loop will basically run until there's no more items in the list. However, instead of 0, I recommend putting 1. Well, it's more of a necessity because the last tile will be the turn tile. So if you delete the turn tile, the player's still going to be on the turn tile while they're turning, and they're just going to fall through space. And they're just going to fall down to their deaths, which is unfortunate. Because remember, in the add new direction function, we call delete previous tiles while we're turning. All right, and just to test this quickly, if we go into Unity and we press play, we go to scene, you'll see that we turn left here, and the previous tiles that came before this, the straight tiles, are removed, but the left turn tile is still there. Awesome. So now let's spawn some obstacles on this route so it's a little more exciting. You know, we don't want the player to bore themselves by just turning all the time. And this is pretty easy. So let's make a new function. Let's say private void spawn obstacle. Make sure it's caps here. And we only want to spawn this obstacle ever so often because this is going to be called every time in this spawn tile function if we pass this spawn obstacle boolean to be true, which we can just put it right here. So right before the if tile type equals tile type dot straight, we can do if spawn obstacle, then spawn the obstacle. And you can do the check here. However, I just prefer to have the check within this function so we can just decouple the logic in a neater way. So let's say we only want a 20% chance of this being spawned. So we can do if random.value is greater than 0.02f, which is float, then return. So random.value returns a float between 0 and 1, inclusive, an inclusive range. And basically we're saying that if this value is over 0.2, then we don't want to run this function. So we have an 80% chance of not spawning an obstacle and a 20% chance of spawning an obstacle. So now that we can spawn an obstacle, let's get a reference to our obstacle prefab, game object obstacle prefab. And we can just call this function we already made, select random game object from list, and we can pass in our obstacles list that we made. Now we can instantiate our obstacle. So we can do game object obstacle equals instantiate. Then we can pass in the obstacle prefab item. We can pass in the current tile location, and we can pass in the rotation of the game object. So let's just call that new object rotation. And then we can add this to the current obstacles list, current obstacles.add, and you can add in the obstacle. Now, the rotation for this is really similar to what we already have up here in the spawn tile function, where we are taking into account the primary rotation of our game object and multiplying this function. So the look rotation function will rotate our tile to look at the current direction that we're going around the vector3.up axis, around the y-axis, so that it can rotate in the proper direction. And this is just exactly the same function that we're going to use. So you can just copy that and we can just scroll down, paste that there. But instead of tile, we can do obstacle prefab. And instead of new tile rotation, we can do new object rotation. Alrighty, so we are calling this function from this spawn tile function, and we also want to make sure to delete the obstacles that we spawned once we can't see them anymore. So we can just use this exact while loop, paste it here. Instead of 1, let's just do 0, since we don't really care about deleting all of the obstacles in the previous path. Instead of game object tile, game object obstacle, and instead of current tiles, which you can actually select the first one, and in VS Code, you can press Ctrl D 2 times to select all the other instances in order. And then you can do current obstacles. And here, instead of tile, destroy tile, we do destroy obstacle. And to test that this worked, let's just over here, when we're spawning our preliminary tiles, let's add in a true here. So there is a possibility of obstacles being spawned. If you press play, and we go to our scene view, you'll see that the previous path is deleted and there are no obstacles. I'm just going to change this layout to tall because this is annoying me. Awesome, so that's basically our tile spawner script. Make sure to remove this true from the initial tiles being spawned. We don't want an obstacle for that. And we can delete these 2 lines where we're spawning a manual tile to see the direction, and we can uncomment our original spawn tile with a random turn tile line. All right, so that is the basics of the tile spawner script. So if I just zoom out and go over a little bit and we scroll down, you'll see that in the start, we're just initializing our lists and our random seed. Then we're spawning a set of straight tiles with the tile start count, the number being the tile start count. Then we spawn a turn tile, a randomly selected one from our list. The spawn tile function basically spawns a tile at the location rotated towards the direction we're currently moving at, adds it to the tile list, spawns an obstacle if spawn obstacle is true, and if we're going straight, then it adds in a offset for the next tile location to be spawned. In the delete previous tiles script, we just do while loops over each of the lists and destroy all of the objects, get a reference to the object, remove it from the list, and destroy the object. In the add new direction function, this is going to be called when the player turns. In the turn tile, we're setting the new current direction, we're deleting the previous tiles, we're determining the placement of the next tile, and this depends on the size of the turn tile, which we have to do some calculations depending on the turn tile to get the correct placement. Add that to the current tile location, spawn a number of straight tiles for a random amount, and then spawn another random turn tile. For the obstacle, we have a certain chance of the obstacle being spawned, and you can actually declare this at the top up here if that's easier, and actually that's recommended. Then we select a random obstacle, we determine its rotation, and we spawn it and add it to the list. And this function just selects a random game object from our list that we pass in. All right, so that was a doozy. Now for the actual fun part where we have to make the player go through the level. First, we need a set of controls for the player to move. And we're going to be using the new or not so new input system for this. Alrighty, and to do that, let's go to our scripts folder, right click, create, scroll all the way down, input actions. And let's call this player controls. An input action asset is a scriptable object file which keeps track of all your controls that you assign for the player. So our action maps are a group of actions, and actions are just things you want your player to do. For example, let's make a new action map and let's call this player. So in our case, we only have one action map, but depending on the use case, you might have multiple, and you can activate and deactivate action maps depending on an area that you may be in. So if you're swimming, you might have different controls than when you're on the land. And I have millions of videos on the input system, and I'll link the main one down below, which I think you should check out, which describes all this in one nice video. And I have more in-depth videos as well. So we want 3 actions for our character. We want the character to turn, we want the character to jump, and to slide. So if we double click the first action or click it and press F2, we can call this turn. Then up here, we can add a new action, call this jump. Let's add another action and call this slide. So for each action, you can have multiple bindings, and bindings are the actual controls on the keyboard or gamepad that you want to relate to the action or associate to the action. So for example, the jump action, we have an action type of button. This means this is a button that you can press either on the keyboard or the gamepad. And if we press no binding and then path, we can type the letter or key that we want to be associated with this binding. In our case, if we type in space, it'll pop up here and we can just click it to add it to our binding. For the slide, we can do the same thing. However, in this case, let's press listen and then S. And this basically listens to input and displays whatever you press here, which is pretty nice. And we can just click that. And then for turning, we can click that. And then we can click the turn action. And let's select the action type to be of type value and the control type to be of type axis. So if you change the action type to value, you can change the control type to be any one of these. And since we are turning, the player will press two keys to turn, either the left or right arrow keys or A and D in the WASD. Those are two buttons. And so the best way to represent that would be an axis, which would return 1 if you're pressing D and -1 if you're pressing A, which is left, and D would be right. So if you go to no binding here, so you can remove this no binding by right clicking, pressing cut, and then in the turn, you can press the plus button and add a positive negative binding. And this adds a binding, which we can call whatever you want. I'm just going to call, which you can call whatever you want. I'm just going to call A and D. Then you can assign the negative binding the path to A or left arrow key and the positive binding to D. Now, if you also want the character to use the arrow keys, you can add another positive negative binding, call this arrow keys. The negative path, you can put it to left arrow, and the positive path, you can put it to right arrow. And if you press either one of these, it'll return the value into the turn action. So once you've set up your input action asset, we can save this asset, close out of this, and then to access this in our player script, which we have not made, we can use the player input manager from the input system package, which we can actually create an empty game object on our scene. Let's just call this player, and then let's add that player input component. It's actually called player input, not player input manager. The manager is for local multiplayer. And then you can drag and drop your input action asset that you made into this actions field here, or you can press this circle button and select it from your assets. And so this provides a set of helper methods to make accessing the input action asset easier from a script. And you can see you can even change the map there. Now let's create a new script. So right click in your scripts folder, create a C# script, and let's call it PlayerController. We can double click that. So I'm going to remove this system collections generic namespace and also remove these functions for now. So this script will control our player. So let's declare some fields that we're going to want to use, and let's make them serialized fields so that we can see them in the inspector, but that they're private so other scripts can access them. So let's set the initial player speed that we want our player to move at. So private float initial player speed, and I just set that to 4. Float. Then we need another serialized field, private float maximum player speed. So this is the maximum speed that we want the player to be able to run at, which we'll just put that at 30. We want another serialized field, private float player speed increase rate. So this is the rate at which the speed increases. Next, we want the player to jump. So we need a jump height, private float jump height. This is how high the player will jump. And we need a gravity value. So let's specify private float initial gravity value, because as the time goes on and the player gets faster and faster, if we don't increase gravity, the jump will stay higher and higher. The jump will stay longer in the air because we're going at such a fast speed. So if you increase the gravity proportional to the increase in speed of the player, then the jump should be consistent with the speed. Alrighty, and then for now that's fine. We want some private variables here. So we want a private float player speed. So this is the current player speed. We want a private vector 3 movement direction. So this is the direction in which the player is currently moving at. So we can just set that to vector 3.forwards as the default. Next, we want a reference to our player input and our different actions. So for that, we need to scroll up and put using Unity engine dot input system to use these types. So we need a private player input, which is a reference to our player input component. We need private input action, our turn action. So this is so that we can easily cache or store our actions in these variables so we don't have to keep accessing them with strings. Then we can do private input action, jump action, and private input action, slide action. And we also need a reference to our private character controller. And we're assuming that we have to have a character controller attached to this game object. So if you scroll up before the class, you can actually put a require component type of parentheses, and we can do character controller. And then after that, we can do comma type of player input. So this makes sure that these two components are attached to the game object once this player controller script is attached, which is important, which can help with some bugs. Alrighty, and now let's do an awake function here to get these references. So for the player input, let's do player input equals get component player input. Then we can do controller equals get component character controller. Now we have to get a reference to our actions. So turn action equals player input dot actions, and then index it by the string that we named it. So we named it turn, and make sure this matches exactly, or else it won't recognize your action and you might be confused as to why your input may not be working. And it might be because you spelled this wrong, and it's cap sensitive as well. Then we want our jump action equals player input dot actions, and we put jump. And then we have the slide action equals player input dot actions and slide. And now for the gravity, I forgot to set up here. We also have to keep track of the current gravity. So we can just put a private float gravity. And then in the awake function, we can put gravity equals initial gravity value. Actually, let's make a start function, and let's just put this gravity equals initial gravity value in the start function, and let's do player speed equals initial player speed in this function as well, which is just how I like to organize things. This is where I usually get things that we need for the scene, and in the start I assign variables and floats that we may need. Alrighty, so we have our actions, and the input system uses events, meaning that when you press something on the keyboard, for example, the input system sends out an event basically saying, okay, the player has pressed down on the keyboard. Now it is up to us, or whoever wants to subscribe to the event, basically listen for the event, and when we receive that event, we can execute some code. It's like you're paying Netflix a subscription fee. You want to know what shows are out and you want to be notified on it. However, if you cancel your subscription, you don't want to be notified anymore because it's too expensive nowadays, you know? So we also have to make sure to unsubscribe when we don't want to listen to these events anymore. So we can do that in the onEnable function. The onEnable function is called when the script is enabled, and it's called after awake. So we can do turn action.performed plus equals, which is the syntax for subscribing to an event. And then we can put player turn, which is a function that we are going to declare in a little bit. Then we can do slide action.performed plus equals player slide. And we can do jump action.performed plus equals player jump. And now when we want to unsubscribe from this, because Netflix is too expensive nowadays, we can do turn action.performed minus equals player turn. Minus equals unsubscribes from listening to an event. We can do slide action.performed minus equals player side. And we can do jump action.performed minus equals player jump. And now we can declare these functions down here. So you can do private void player turn. And this function actually will pass in an input action dot callback context. And this basically has information on the action that we press, and we're going to use that to read the value. Then we can copy that and paste it 2 times. And instead of player turn, we can do player slide and player jump. Awesome. So let's start with movement, which is the most obvious one that we should do first for all the complicated actions here. So let's do that in the update function, private void update. And now we want to move the player forwards depending on the movement direction that they're currently going at. So since we're using the character controller, we can do controller.move, which is a function, transform.forwards times our speed, player speed, times time.delta time to smooth it over the frames. And we're using transform.forward because we're going to be rotating the player depending on what direction they're turning. And once we rotate the player, their forward direction will be in the direction of the tiles. All right, so now let's just implement jumping since it's not that complicated either. So to jump, we want to first make sure that the character is already on the ground, and the character controller does have an IsGrounded function. However, it's very unreliable, I've found, and not very accurate. So let's make our own called private bool IsGrounded. And let's actually pass in the length of the raycast that we want to cast downwards. And so a raycast is basically just a ray cast in a certain direction. So a ray has an origin point where we start the ray, and then it has a direction. So we're casting the array in this direction. In our case, we have our player, which is going to be a nice capsule. It's kind of sus. And so we're going to shoot a ray from here downwards. And let's say our ground is here. If our array hits this ground downwards, then we are grounded. However, if we're jumping, our ray with a short length won't hit the ground and it'll return false. So it's not grounded. However, there is a little problem with the tiles where the tiles are loaded one after the other. And so sometimes there can be a small space in between the tiles, super small that you wouldn't notice. However, if we're casting a ray on every frame downwards, and in this particular frame, the player is above this crack in the floor, it'll shoot the ray downwards and it'll be like, there's nothing here. We're not grounded. Sad face. So to get over that, there's a couple ways. In this case, instead of only relying on one ray cast, we'll rely on 2. So we're going to shoot one from behind the player and in front of the player. And if either one of them are true, then we're grounded. Yay! I hope my nice diagram made sense. So first we have to have an origin point for our raycast. So we can do vector3 raycast origin, and then we're going to say first for the first raycast, we can just do transform.position. However, we want to move this transform position to the bottom of the character. And we can do this raycast origin first dot y minus equals our height of the controller, which is this is a character controller attribute divided by 2. The height divided by 2 is half of the controller height, and the transform position is in the middle of the controller. So see, this is our transform position, and then this is the height. Half of the height is this. So we're basically subtracting half of the height so that our new origin is around here. And I found that it's best if you add a little bit offset to it, so 0.1f, so that it doesn't accidentally go through the ground. All right, and for the second raycast, we can do vector3 raycast origin second, and we can equal that to raycast origin first. However, in this one, let's move this one a little more forwards than the first raycast, so we can do raycast origin second plus equals transform.forward, which is the forward direction of the player times some length, so 0.2f. So this just moves the origin a little bit forwards. And actually before that, let's do raycast origin first minus equals transform.forward times 0.2. So this is just to make sure these are equal length from the center of the character. And now we can cast a ray here. So if physics.raycast, we cast the first ray, raycast origin first, and now we want to cast a ray down. So we can do vector3.down, then we can do out raycast hit, and this will produce a variable called hit that we can access the information on. We can pass in the length of the ray, and then we want to only make sure this ray cast hits certain objects, in this case, the ground. so we can do a ground layer, which we will declare in a minute. And this is so that it doesn't accidentally hit our player, for example, or another object. And then we can do OR and paste the same thing we wrote here, physics.raycast, but instead of the first raycast, the second raycast, and we can just call that hit 2, parentheses. If either the first one or the second one hits the ground, we can return true, else we can return false. And if you do want to debug these lines to make sure they're being drawn correctly, we can do debug.drawLine, raycast origin first, the direction we want to shoot it, so vector3.down. You can put the color, so color.green, and you can put the seconds on how much it lasts. So you can put, you want it to last 2 seconds, and this will draw a debug line in the inspector. And you can copy that, Shift-Alt down, and replace first with second, and you can replace the color to maybe red as an example. Alrighty, so now let's declare this ground layer. So if we scroll all the way up after the initial gravity value, we can do serialize field, private layer mask ground layer. And a layer mask lets you specify layers that you want to use. Alrighty, so if we go, that's not the right page, back to the inspector here, we can go into player and add our player controller. As you see, it adds the character controller for us, which is really nice. The ground layer, we have to set a ground layer. So up here in the layer, let's add a new layer, and in 6 or whichever one you want, just type in ground. Then in player, we can select the ground layer to ground here. And now we want to mark the ground as ground in our prefabs. So if you go to the Temple Run prefabs, then in the left one, we're going to want to set the layers to ground, which I'll just select the top one here, left, and select ground. And yes, let's change the children. So now all these children will also have the ground layer. Click Control S to save. On the right, let's add this ground layer. Yes, change this children. In the sideways, let's add this ground layer. Yes, change the children. And in the straight, let's also add the ground layer. Alrighty, so for our player, we need a mesh to actually see the player in the scene. So if we right click on the player, let's add a 3D object capsule. Now we have our nice player mesh, which I'm just going to call mesh. And now under the mesh, I'm going to add a 3D object cube. And this is going to be like the glasses, the VR glasses of the character. And it's just going to kind of tell us what direction the character is currently facing. And it's more for us to know. So if we see the mesh, the Z axis is that way, which is the blue one. So let's just put it like that. So now we have some nice glasses on our sus character. So if we go to assets, let's create a new folder called materials. Double click it, right click, and create a new material. Let's just call this red. So let's put that red in this albedo. And we can just drag that new color red onto our glasses so we can better see the glasses. Awesome. So our player, let's put the position to 0, 0, 0. Our spawn manager, let's put the position to 0, 0, 0 as well. And then the player, let's put it a little bit above the spawn manager so that it spawns above the floors. So you'll see that it does spawn indeed, and it does go, but it definitely did not go in the right direction that I was thinking it was going to go in. And that's probably because I actually don't know why that's happening. Ah, that's silly. I set the player speed to the initial gravity value instead of the initial player speed. And since the gravity value is negative, it's going in the opposite direction. Teehee. Okay. Anyways. Okay. Now we see our player is going forwards, but there's no gravity. That's why he's floating in the middle of the air. And you know, if you click player and press Shift F, you can actually kind of zoom in and then see more in depth. Anywho. So let's program some gravity so that the character actually goes on the floor. It's kind of important, which is pretty simple. After the movement, we can do, and this is ripped off of Unity's character controller documentation. If we're grounded, and let's set the default length to 0.2, since I found that to be a good length. If we're grounded, and our current velocity, which we don't have declared anywhere, So if we go up here, let's declare this private vector 3 player velocity to keep track of the velocity of the player. And we go back down. So if we're grounded and our velocity, player velocity dot y is less than 0. So if we're grounded and gravity is pushing us down, it might create this weird glitch effect where it's kind of like glitching downwards because it's trying to be pushed down onto the floor, the player. So we can just set the player velocity dot y equals to 0. And this also acts as a way to reset the gravity on every frame. And this also acts as a way to reset the gravity on every frame. So now we can actually add gravity. So player velocity dot y plus equals gravity. So we're adding gravity, which is negative, times time dot delta time. And this is important to add the delta time. Then we can do controller dot move the player velocity. And you also have to times it by delta time here as well. If you don't do it, it'll not work properly. I don't know why the character controller, you have to do it like this, where you have to times in time delta time twice, but c'est la vie. Okay, so now if we go back into Unity and we press play, you'll see that now our player is on the ground, and you see it's grounded because we have this raycast, and you see it's hitting it downwards, and the raycasts are actually moving down, which is interesting. I don't know why it's doing that, but I guess it doesn't matter for our use case. All right, so now you see that we are on the ground when we press play because we have gravity. However, for some reason, we can't jump when I press spacebar. So let's get to the root of it. And that's because we actually even haven't put in the player jump. The length of this video is getting to me. Alrighty, so now let's just implement that jump while we're at it. So this is going to be pretty simple. So first we want to check if we're grounded. So if we're grounded, then we can jump. So we can add in the player velocity, since that's what we're using to move it, in the character controller, .y plus equals, and we gotta bust out some physics here. Math f dot squared, squirtle, and then we can do jump height times gravity times some other value that you want to add. So in our case, we can just do -3, and this is the famous physics equation where v squared equals v initial squared plus 2 acceleration delta of x, which is the difference in the beginning of x and the end, which the delta is x final minus x initial. And basically this is a way to calculate velocity given an acceleration and an x. In this case, an x can be the height. So basically, instead of doing v initial squared, we're just doing v plus equals, and then this squared, we are square rooting it so that we can square root this whole function. And that's why we have the math f squared. And then we can do 2 times a, in this case, acceleration is our gravity, times the delta of the x, which in this case is just our height. So you can see here, we basically have that, but we are multiplying it by -3 because gravity is negative and we want the player to go upwards when they jump. So we have to multiply it by a negative number, and I guess Unity just chose 3 because it's a good value that they found. And now once we calculate the velocity, we can do controller.move. We can put player velocity and then times time.delta time. Alrighty, let's go and test it. I hope you like my singing. Okay, and now when we press play, if we press jump, you'll see that our player jumps. Yay! And in the player, you can mess around with these values, like the jump height. So if we put the jump height to 3, you'll see that we jump much further. And if we set the gravity to a larger number, it's larger. Whee! All right, now that we have that implemented, let's implement the player turn functionality. So once we press the keys for turning, we want to check if we're actually able to turn, aka that we're on a turn tile. So you can actually get the current keys that the player is pressing on in this function by doing context.readValue. And this will return a type of float since this is a axis value, or axes. I don't know how to pronounce it properly. And if we're pressing D or right arrow key, this will return a 1. If we're pressing A or left arrow key, this will return a -1. And so now we can actually check if we're able to turn And I'm just going to do this in another function. So if we're able to turn, so let's do private void check turn, and we pass in the value of our turn. So we're going to change this to, instead of void, we're going to return a vector 3. And this is because, as you see, if you go into our prefab under assets, temple run prefabs, and if you click the left one, for example, you'll see that there's a pivot that I assigned here. And this pivot makes it easy for us when we're running towards this turn tile and we press turn, the player will teleport to this pivot location, rotate towards the new direction, and continue running straight towards that new direction. And this just makes it easy for us in terms of math, so we don't have to calculate exactly where the player needs to turn in order for them to remain in the center. And so if you see in the parent, under the tile script, we have assigned the pivot here. So if we go to edit script, we assign the pivot to a public transform pivot. And so first we're going to check if the player has pressed the turn. Then we're going to check if they can actually turn, meaning if they're in the collider, and we're going to use a physics overlap sphere to determine if we are in the collider. And then if we are in the collider, we're going to get access to the tile pivot, teleport the player to that location, rotate the player towards the new direction, and then they can continue running. So that was a doozy, but it's pretty easy to implement. So let's get to it. So first of all, in this check turn, we can do physics.overlap sphere, and this creates a sphere, an invisible sphere, at our transform.position, which is where we currently are, with a radius of 0.1 float. And this will basically check if we're overlapping with any other colliders. And this is a sphere in this case. You can also do overlap box or some other object. And we have to pass in the layer that we want to check that we're colliding against. In this case, let's just put turn layer, which we'll declare in a second. And this returns an array of colliders. So we can do collider hit colliders equals what we just wrote. And now we can check if there's actually anything in this collider array. So if hit colliders dot length does not equal 0, so if it's not empty, then we can assume that we are turning in the correct location, and we can get a reference to our tile to get the pivot. So if we do tile, for example, you'll see that it won't work, and that's because the tile is under the namespace temple run. So if we go up to the player controller, before the player controller class, we can do namespace temple run. And then if you want to make it more specific, you can do temple run.player. And then you can scroll all the way down and encapsulate this class within this namespace. And now, before we go back to what we were doing, let's just declare that turn layer up here. So we can do a serialized field, private layer mask turn layer. And now it won't throw that error anymore. Awesome. And now, for example, if we do tile, you'll see that it recognizes tile because we are in the namespace. Even if we're in the temple run player namespace, we still have access to the temple run classes and functions that are available. Okay, so now we can do tile equals hit colliders at 0. So the first thing that we're hitting, which we should only be hitting one collider. Transform.parent. So if you remember in the prefab, the turn threshold, which is the collider, is a child of the parent, and the parent has the tile script. So if we go .parent.getComponent tile, now we can get the type tile type equals tile.type. And here we're going to check if we are actually turning in the correct way. So for example, if we can only turn left and the player decides to turn right, obviously that's wrong, so they won't be able to turn. So we can do that here with an if statement. So if the type of the tile type equals tile type.left and our turn value equals -1, then we can return the pivot position. So we can do tile.pivot.position since pivot is a transform. Okay, and now we have to do this for the right and the sideways. So instead of making 3 if statements, you can also just put everything in one, whichever one you prefer. So let's just copy this, if type equals left and -1. And after that, we can do, or let's just put this on a new line and paste it. If the type equals right and the turn value is 1, or we're going to paste that again. if the tile type equals sideways, then if it's sideways, we don't really care what the turn value is because they can turn either way. So we're getting the direction of the turn tile and we're checking it against what the player has pressed on the keyboard or gamepad. So if we don't find anything, we want to return null. So down here we can do return null. And you'll see that we can't do this because this is a vector 3 and we have to return a vector 3. So as a workaround for the vector 3, you can put it as nullable by putting a question mark after the vector 3. And the question mark is called nullable and means that this can either be a vector 3 or be null. And we can check against that. So if we scroll back up to the player turn function, now let's call check turn and we can pass in our context read value float. And then we can do vector 3 turn position. And of course, since this is nullable, it's saying there's an error, can't convert vector 3 to vector 3 nullable. So just declare that as vector 3 nullable. And now let's check if we actually have a turn position. So if turn position dot has a value, so if it's not null, however, I like to actually negate it and do the opposite just to make the code cleaner. So if we don't have a value, then let's just return from this function before we do anything else. Now we want to rotate the player in the direction that they want to turn and that they can turn. So we can do vector 3 target direction. And now we have to use some quaternion magic to rotate the player towards that direction. And for that, we're going to use this function called angle axis, which creates a rotation over an axis with a certain number of degrees, which is perfect. So we can do quaternion.angle axis, I have no idea. Axis sounds better. And now we would want to turn the player 90 degrees, either left or right. The context read value float only returns a 1 or a -1. So we can actually multiply that by 90 times context.read value float. And so this is the degrees that we want to turn if we're turning left. If we're turning left, it'll be -90. And then we want to do this around the vector 3.up axes. And so this returns a quaternion. However, we also want to take into account the current direction that we're moving in. And to do that, we can multiply this by the current movement direction that we are going in. So let's say we're going in the positive Z axis, and now we want to turn left relative to our current direction. Well, to do that, you'd multiply how much you want to turn by the current direction. And so I made a small mistake in explaining this. If we're rotating the player, we don't need this because we have already the current rotation of the player with its transform rotation, and we can just rotate it to the side. But instead, this will be used to feed into the tile spawner add new direction function. So this target direction will be fed into this add new direction. And how will we do that? Well, we will use events. So if we scroll all the way up, we can make our own event here. And let's make it a serialized field. And we can do private unity event. I'm going to use a unity event. And we can pass in a type. So we're passing in a vector 3. So this is the parameter that we want to pass to the event. So whoever listens to our event will get a vector 3 once the event is invoked or called or performed. We can call this turn event. And for this to work, we need to import the using Unity engine.events namespace. And now you see here, we can call this event and then we can have another script subscribe to it. And this is to avoid having hard references to scripts that don't need them. For example, another way to do this is for the player controller to get a hard reference to the tile spawner script, maybe by dragging and dropping it into the inspector, for example. And that creates a dependency between these two files, which means that this file wouldn't be able to work without the tile spawner. However, if we use events, the player controller will still work, and anyone who wants to listen to the event is responsible for subscribing to it, and it decouples code and just makes our lives easier for debugging and bugs. So if we go back to the player turn here, now we can invoke the event. So turn event.invoke, so we're calling it, and we can pass in our target direction. And so now in the tile spawner, this function add new direction will be called. If we go back to the Unity editor, for example, and we go to player, you'll see that under player controller, we have this turn event because we made it a serialized field. If we press plus here, we can drag in our spawn manager, then click tile spawner, and this is the function that we want to call when this event has been invoked. And in this case, we want to call this add new direction function, and this will get passed our new direction from the player controller into the spawn manager. Alrighty, so now for actually turning, let's turn the player. So let's make a turn function here, and let's pass in where we're actually turning our input so that we can know where to turn. So context.readValue float. And then let's also pass in the pivot position that got returned with turn position. So this is where we're going to teleport the player to once we turn. So if you scroll down, let's just make a private void turn function, and let's pass in a float turn value. And let's pass in a vector3 turn position. First, let's teleport the player to the correct position where they need to be. So first, let's get our current player position. So we can do vector3 temp player position, and we can make a new vector3, and we can pass in the values where we want the player to teleport to. So we want the player to go to the turn position .x. We want the player to keep its current y position, so transform.position.y, and then we want the player to also go to the turn position.z, because we're moving in the x and z axes. And so something you need to do before changing the player position manually, usually you can do it by setting the transform position, but since we have the character controller on the player, you actually have to disable the character controller. So controller.enabled equals false. Then you can set the position, transform.position equals temp player position, and then you can enable the controller back up again. So if not, it won't really let you change the position. It'll just be weird. And now let's rotate the player towards the direction where they need to turn. So we can do that with a quaternion, which I'm guessing you love quaternions by now. We can call this quaternion target rotation. We have a function called quaternion.Euler, or Euler, whatever the cool folks say nowadays. And this returns a rotation that rotates a certain amount of degrees that you want, either on the X, Y, or Z axis. So in this case, we only want to rotate 90 degrees on the Y axis. So we can put 0 for the X. We can put 90 times our turn value on the Y, and then we can put 0 for the Z. However, this just rotates it 90 degrees and doesn't really take into account our current player rotation. To do that, we can do transform.rotation times that new rotation that we want to turn it in. And usually the rule is that with quaternions, you put what you want to impact first, and then you multiply it by how much you want to rotate it by. So now we can set the transform.rotation to our new target rotation. And now we can set the movement direction of the player to the new transform.forward of the player, and we can just normalize it, which results in a vector of length 1, since we only want the direction and we don't necessarily want the length of the direction that we're moving in. All right, and now a small error here in the player turn function. You'll see that when we call turn, it doesn't accept the vector3 nullable. So we can do turn position.value, and it returns the actual value of the nullable vector3. Alrighty, so let's check how this works here. So first we need to declare a turn layer. So if we go to layer here and we add a new layer, let's add a layer called turn. And now let's just make sure that our game objects have this turn layer, in specific the turn threshold object, which has the layer ground. So we want to change that to the turn layer. And for the right game object, we also want to turn the turn threshold to turn layer. I'm saying turn a lot. Sideways, we want to put the turn, which I should have called turn threshold, to the turn layer. And make sure you do that or else it will not work. Then under the player controller, make sure to set the turn layer to turn. Okay, and now if we click play here, you'll see that we have this player, and whenever a turn is coming up, hopefully soon, we should be able to turn properly. So it's gonna take a while. So now if we press to turn, you'll see that the player has turned, the previous tiles have been deleted, the next set of tiles have been spawned, and now they can continue on. Awesome. All right, and so now let's do the sliding functionality, which is pretty simple as well. So first we want to slide only if we're not already sliding and if we're grounded. So let's perform a check for that. So if we are not already sliding and we are grounded, is grounded, then we can slide. For the sliding, we need to declare a boolean. So if we scroll up, we can do private bool sliding equals false. And for the sliding, we're actually going to make a sliding animation for the player. So it actually looks like they're sliding. So if you go in the editor and you click the player here, we can add a new animator. So we can add an animator component, which will keep track of our animations that we can run. And if we go to our assets, we can right click and create a new folder, and we can just call this animations. And we can right click and create a new animator. So we can create an animator controller and call this the player animator controller. And then for the player, we can just drag and drop our new animator into the runtime animator controller component. And if you double click, you'll see that we don't have any current animations. So let's go add an animation. If we go to window, animation, animation, this is a window where we can create animations and put them in our animation controller. The animation controller allows us to have multiple animations and configure them and the transitions between them, while this just lets us define single animations. So to assign an animation to our player, first we have to select our player, and then something will show up here. We have to click create to create an animation clip for our player. Then under the animations folder that we just created, we can call this the sliding animation.anim and click save. And now what we can do is create an animation. So to create an animation, just click this recording button. And now any changes that we're going to make to our player will be recorded and displayed here in this animation window. So first we want to start the player off normally. Then after a little bit of time, we want them to start sliding. So for the player here, we can rotate them on the X towards the negative direction. And so we want them to slide. So it's going to look something like this. And you'll see that when we do that, only the mesh looks like it's sliding. The actual character controller will remain still. So we're going to need to also adjust the collider in the script to shrink itself so that it doesn't actually hit our obstacle when we slide under it. Then after some time, we want to put the player back. So the rotation, I put it back to 0. And if we click play now, you'll see that we are rotating and it looks kind of funky. So you can actually kind of drag these keyframes around, and these keyframes have our rotation that we set. As you can see here, it says player rotation, and it displays the value that it's currently at over an X amount of frames. And you can just adjust it until it looks okay. I think for the sliding, we might want to do it a little lower so it looks more realistic. All right, awesome. So click Control S to save your animation. Then in the animator, you can double click it and it sets the sliding animation as the default. And we don't want this to be the default because we only want this sliding animation to be called when we call it. So let's actually create another animation for our player. So right click and create an animation, and let's just call this the running animation. And let's set that to be the default. So you can drag that into the animator controller and right click it and set as layer default. And so this will be our default animation. And once we call sliding from our script, we can right click and make a transition to the running animation once we're done sliding. And you can see if you click the animation transition in the inspector, you'll see kind of how it transitions from sliding to running over time. Then you would extend it this way so that it's sliding longer and it runs for a shorter amount of time. And this is important, has exit time. We want this to be checked so that this will exit when our animation has finished playing. All right, so let's call this from our script. So first, let's get a reference to our animator here. So if we scroll up, we can do private animator. And if we scroll all the way up, we can actually require this component as well. So we can require a type of animator on this script to make sure the component is attached. And then in the awake function, we can do animator equals get component animator. And now that we have our animator, we can get a reference to our sliding animation, which you can set up here. I'm just going to set a new variable called private integer sliding animation ID. So what you can do is get a reference to the animation ID of the sliding animation as so. Sliding animation ID equals animator with a capital A string to hash. And we can add in the name of our animation sliding. And this is so that we can get a reference to our animation without having to type in a string all the time. Because if we type in a string all the time, we might mess up and misspell it or put it lowercase and it might not recognize it. If we're only doing it in one place, it's easier to track down why it's not working. So this is a reference to the animation ID within our animator. And now we can actually play this with our animator variable. So if we scroll down, we want the player to play this animation and also decrease their collider so the collider doesn't clash with the obstacle. And the best way of doing this is a coroutine. So we can declare a coroutine here, private IE numerator. We can call this slide. And you'll need the system.collections namespace for this. So a coroutine is a function that can pause execution until a certain condition is met or multiple conditions are met. So we can shrink the character controller, we can play the animation, we can wait until the animation is completed, and then we can set the controller collider back to its original height. So let's do that. So let's do vector 3. Let's get the center of our controller. So original controller center. And this is to shrink our collider. So we can do controller.center. Then we'll declare a variable called vector3 new controller center. And we can equal that to the original controller center. This is just to declare values. We can also declare a variable called sliding equals true so that we can't slide while the character is already sliding. And just for simplicity's sake, let's do animator.play. And let's play our animation, sliding animation ID. And now let's wait until this animation has stopped playing. So we can do yield return new wait for seconds. So this waits for an X amount of seconds. And now we want to wait for how long this animation takes. And for simplicity's sake, let's scroll all the way up and let's get a reference to our animation clip, slide animation clip. And we're doing this because in the animator, you do have your animation clip. However, it's a little hard to tell how long our current animation is. You can do it, it's just a little more complicated than just getting the reference to the animation clip directly and finding the length. So if we go back down to our slide function, now we can wait for however long our animation clip is. So slide animation clip.length. And we'll actually be changing this a little bit as well. And then after that, after our animation has played, we can put sliding equals to false. And then we can do the other calculations of setting the collider back. So let's do that here where we shrink the collider. So let's do shrink the collider, play the sliding animation. All right, so now to shrink the collider, let's just make it half of the current size that it is. So the collider will be only half of the player size. And once we make the collider half of the player side, the collider will still be at the center of the player, which you can see the collider is here at the center of the player. And what we're going to want to do is in the character controller, as an example, you can change the height of the character controller and you'll see that once you make it smaller, it still remains centered. So we not only want to change the height, but we want to change the position to 0.25 from the floor of the player. So let's imagine right now it's at 0.5. This is 1, the top of the character controller, and this is 0. Right now, the center is at 0.5. If we shrink the collider in half, the collider is going to be this size, and we want the center to be right here, 0.25. So we can do controller.height divided equals by 2. Now we can change the center. So new controller center.y minus equals the new controller height, controller.height, which is half of it, divided by 2. Because remember, we want it to be in the middle of the height. And now we can set the controller.center equals to the new controller center. All right, and now after this is completed, we can set the controller height and the center back to normal. So controller.height times equals 2, and this is just a shorthand for multiplying and dividing. And then we can set the controller.center back to the original controller center. And I'm just going to put this sliding equals false to after this is completed, and the sliding equals 2 to before all of this calculation. And here we can do set the character controller collider back to normal after sliding. All right, and now in the player slide function, we can call start coroutine to start the coroutine. We can pass in our function slide. All right, so now if we go into the editor and we go to our player here, we have to pass in our animation clip. So you can click the circle or drag it in and click sliding. And now if we click play and we click slide, you'll see the player is sliding. And you see when we slide, the character controller height is now 1 instead of 2 where it was originally. However, you see that when we slide, the player kind of slows down and kind of jumps a little bit. And that's because we're actually rotating the entire character controller instead of the mesh itself. So I actually recommend whenever you make a player, instead of putting the animator on the player with all the scripts for movement, I recommend making the mesh a child of the player and putting the animator there. So let's right click and copy our animator component. Let's just remove that component. Then if we go to the mesh, you can right click and paste the animator component. And now what we're going to do is that in the player controller script, instead of requiring a type of animator, and I realized this a little bit after, so apologies for this mistake. Then here we can do a serialized field private animator. And instead of getting the reference here to the animator, and in the awake function, we can also remove this animator get component. We're just passing in the animator directly into our player. In the inspector, we can just pass in the mesh into the animator and it will put the animator there. And now we can remove this animator component from our player game object. And for our sliding animation, you'll see that it matches the rotation perfectly. And in the mesh, you can also disable the capsule collider since you don't need it, or just remove it. Also, I'm gonna just remove those raycasts because they are kind of annoying. In the player controller is grounded function. I'm just gonna comment out the debug draw line. All right, and so it's getting a little harder to debug. So let's just add in a camera here so we can track the player more easily. And we're gonna be using Cinemachine for this. So make sure you have it installed in the Window Package Manager Unity Registry, Cinemachine. You see we have Cinemachine installed here. And so let's just add a Cinemachine here. So here we can right click, go to Cinemachine and add a virtual camera. And a virtual camera basically tells the actual camera how to move and rotate. It just makes it easier for us to program awesome camera functionality with a virtual camera. So the main important ones are the follow and look at. So we want it to follow our player and also look at our player. And then you can go down to aim and body. And here are the main settings that we can adjust. So you see the follow offset is how far away it is from the player. And you can offset the Y and the X if you wanted to. It will rotate around the player, but I don't want to rotate it on the X. The damping basically smooths the camera while it tries to catch up with the player. So if you have a smaller number, it won't be as smooth. And if you have a larger number, it will be more smooth. However, you don't want to put too large of a number because then it'll lag too far behind the player. And so you can just adjust these values here. Awesome. Another thing I want to do is to give this more of a mobile game feel, we can go to under the game settings, free aspect. We can actually put in a new aspect. I already have one called phone, which is a 19 by 16 aspect, you can add one and just call it phone or mobile, and then put an aspect ratio of 9 by 16, which is the resolutions of the phone. And then you can click that and it'll make the game view look like you're on a phone. And it'll make it just a little bit easier to adjust. And so the main two values I'm gonna change are the tracked object offset and the follow offset of the body transposer. Awesome, so now we have a camera setup. It was pretty easy. And you'll see in the main camera, make sure you have the Cinemachine brain, because that's how the Cinemachine virtual camera communicates with the actual main camera. And so you see now we have our camera following our player. Nice. We can slide, we can jump. Awesome. Alrighty, now that we have this set up, let's go and implement the GameOver logic. Basically, if the player has collided into something, if they turn at the wrong location, or if they just don't turn at all and run off and fall, we want all of those to trigger a game over condition where it will take them to the leaderboard where they can submit their name and score into our leaderboard, and it will update it on the server. And we'll be using 8Locker for this integration, which is totally free for the first 10,000 users every month, which is a lot. And here you see we can create and edit leaderboards, connect them to missions, leveling achievement triggers, and more. So first, let's do the logic for the game over. So let's scroll down and let's make a function here called game over. So private void game over. We're going to call this when the game is over. Let's just put a debug.log there, and this will print out something on the console, and let's just print out game over to make sure that it actually works. So the first condition is that if they turn in the wrong location. So we can go up to the player turn, and you'll see that right here we say if the turn position does not have a value. So if the player has been turning and we check the turn and this does not return a vector 3, that means they've turned at the wrong location and we want to call game over. Another game over condition is if they fall off the map, if they don't turn correctly. And we can easily do that by going to the update function. And in the first line, we can just check by shooting a raycast downwards, let's just say 20 meters. And obviously, if the raycast doesn't hit anything for 20 meters, we are floating. And we use a value like 20 because we want to make sure the player isn't actually jumping. And if the value is 20, it will definitely hit the floor within that range. So if we can just do if is grounded, and if you remember, we passed in a length here, so we can just pass in a length of 20. So if we are not grounded with a length of 20, and once again, this name isn't really great in this case, is grounded. Instead, you can do shoot downward raycast as a name for that function. But for now, I'm just going to keep it to is grounded. So if we shoot a raycast downwards and it's not hitting anything, then let's just call game over. And then we can call return from this function, and return in an update function will stop calling the update function every frame. All right, and the last condition is if we collide into something, whether that be an obstacle on the ground or the sliding obstacle. And so the character controller has a function that we can use for this, and it's called private void on controller collider hit. And this is called only if you have a character controller attached to your game object. And this takes a type of controller collider hit, and let's just call that hit. So this will be called when we collide with something. And now we want to check with what layer we're colliding with. So we want to check if we're colliding with an obstacle. So we're going to make an obstacle layer, which if we scroll all the way up, we can add up here a serialized field. And same as before, we can do private layer mask obstacle layer, and we have to assign that in the inspector later on. All right, and now if we scroll all the way back down, now we can check the layer of this. So for the controller collider hit, you see that we can access the layer by doing hit.collider.gameObject.layer. And so this is the layer that the collider is currently on. Now we want to compare this to a layer mask. These two things are very different. A layer mask is a bit mask that represents all of the possible layers and defines them as true or false. So we have 32 layers, and a bit mask is basically a binary number of 0 or 1s. And if it's 0, it's false. And if it's 1, it's true. All right, so back to Photoshop to do some nice maths. some big maths here. So once again, we have 32 layers, and in the binary representation, we have two values, 0 and 1. So let's say you wanted to display the number 4. Since we have two values, we have to find the equivalent of 4 to the power of 2. And this one's easy. 2 to the power of 2 is 4. So you'll see that we have the exponent 2 here. That means we have to move over 2 times in the binary number to represent 4. So, for example, that means we have to write down 2 zeros and then a 1. This value is 2 to the 0. This value is 2 to the first, and this value is 2 to the second. So you see it just increases an exponent, 0, 1, 2. So this is a small intro into the binary numbers, but basically in a layer mask, for example, we have 32 layers, and the way they represent the layers is through a bit mask. So in a bit mask, you'd have 32 numbers, 0, 0, 0, 0, 0, 0, 0, and imagine that for 32 times. And so each of these zeros represents a layer. So let's say this is the first 0. This represents the first layer. This represents the second layer, the third layer, the fourth layer, etc. So let's say we want to have a layer mask where we want the obstacle layer to be true. And let's say that that obstacle layer is number 4 on the unity list. So right here. Then the bit mask would look something like 0, 0, 0, 1, 0, 0, etc. And so we want to compare this bit mask with our layer. So let's say our layer is 4. So how can we compare 4 to 1, 0, 0, 0? Well, you can use the left shift property. So left shifting basically means multiplying by 2. So if you have 0 and 1, if we multiplied this by 2, it would move the 1 over to this side. As you see, we shifted the 1 to the left. So the operation that we want to do would look something like this. 1 shifted left 4 times. And that would look like this. We start with 0, 0, 0, 0. If we do it the first time, we have 0, 0, 0, 1. If we do it the second time, then we have 0, 0, 1, 0. If we do it the third time, it will look like 0, 1, 0, 0. And in finally the fourth left shift, it would be 1, 0, 0, 0. And now we can compare these two values. So how do we compare 1, 0, 0, 0 and 1, 0, 0, 0 in binary operation? The AND operator allows us to compare two binary numbers by comparing each sequence and seeing if they're the same. So in this case, if we do 1, 0, 0 and 1, 0, 0, 0, this will return 1, 0, 0, 0 because 0 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, and 1 is 1. So this returns the same value. And now we can just compare. Is this value equal to 0? If it is not equal to 0, then we are on the correct layer. Yay! All right, so back to Unity, hence that little small explanation. So we can do one left shift, let's put that in parentheses, with the layer. And this isn't the double AND that we usually do. This is the bitwise AND operator. And we can do our obstacle layer. And if this is not equal to 0, and let's put this in parentheses, then game over. All right, so now if we go into Unity, let's set our obstacle layer here. So under player, let's add, so we select the game object, we can add a new layer. We can just call this obstacle. Then under player, we can go to the player controller, select the obstacle layer to obstacle. Then let's go into our prefabs, temple run prefabs, click obstacle. Let's set the layer to obstacle. And yes, let's change the children as well. If we click the slide obstacle, let's do the same thing as well. Yes, change the children. All right, and now if we press play here, now if we turn in the wrong direction, you'll see it says game over. And let's increase the player speed here a little bit. And so now if we run off the map, you'll see that it says game over and it keeps printing out game over. And I made a small mistake in explaining the update function. If you call return, it doesn't actually stop the update function. That's why it keeps getting called, because it does call the game over. However, it doesn't call any of this other functionality. And now one thing I'm going to do is the current speed of the player speed. I'm just going to put it as a serialized field so we can actually change it in the inspector for debugging purposes so that we're not going super slow while debugging. So now if we click on the player here and let's increase the speed by dragging, you'll see that now we're going pretty fast. We can turn at the right location, and if we hit this obstacle, it prints out game over. but we can slide and it continues on, which is pretty neat. And you can change all the obstacle randomness so it spawns more obstacles and such. So let's see, now we have this obstacle. Let's jump over it and game over because I pressed the wrong button to jump. This is actually pretty fun. Whee! And you can change all these values. Okay, this is tricky. Okay. Woo! And yeah, just make sure to take breaks and, you know, kind of play with your code a little bit. You know, it's not all about coding. It's about having fun and testing out your code and seeing the bugs and then getting frustrated that nothing works. Anyways, cool. So we have that game over logic. Now let's actually do something when the game is over. So to make this decoupled, let's just shoot out an event and have other scripts responsible for subscribing to the event and doing certain functionalities. So let's go all the way up, and right here where we have this turn event that we previously declared, let's just copy and paste that. And instead of a turn event, let's do a game over event. And the game over event, we're going to want to send over an integer, which for now we'll just send over 0, but this integer will be our score. So we also need to implement score. So if we scroll back down, now in this game over, we can do game over event dot invoke, and we can send our score, which we don't have a score yet, but we will declare that soon. And now we can actually disable this game object. So you can do game object dot set active equals to false, since we don't want to do anything else with this game object. All right, now let's do the score functionality. So let's scroll all the way up and let's declare a score variable. So the score variable, let's just do private int score, and let's equal that to 0. We're going to want a UI that updates the score in the canvas. And so to do that, let's also just make another event where we send out private Unity event, and let's send out that integer score update event. And so the UI will be responsible for subscribing to this event and updating the UI. And this is just to decouple things. We don't want everything to be in this player controller. We don't want hard dependencies between different scripts that don't need it. All right, so how are we going to do the score? It's pretty simple. For the update function, if we scroll all the way down, let's just put it right here, score functionality. Now let's just do the score based on the amount of time that they've been playing the game. So we can do score plus equals. Let's do a score multiplier times the current time. So time delta time, which is the time that passed between the current and previous frame. And now we can do score update event dot invoke, and we can set a score here. Now you'll see the score is a integer and we are timing it by times.delta time. So we're gonna go and declare this value, score multiplier. Oh, I just realized I have this GeForce thing just popping up here. Oop. And now, since we're gonna make this a float, let's actually cast this value to an integer when we send out the score update event. Because the score update event, we want it to be an integer. We don't want the player to see a bunch of decimals everywhere, right? So we can just copy the score multiplier, and we can go back up to where we declared the score and do a private float score multiplier. And now we can make the score a float, and then a little bit more up, we can do a serialized field and do a private float score multiplier. And we can just put that as a 10 for now. All right, now that we have a score and a game over event, if we scroll back down to the game over event, and apologies that we're scrolling up and down, we can just cast that to an integer. And now, since we have this functionality in place, let's implement a game over screen. And after the game over screen, we'll increase the speed of the player proportional to how much time they're in the game so that it's more challenging. And then we'll do progression and unlockables so that the player can gain experience points and unlock certain items as they progress through the game. Okay, so go to the Unity scene and go to scripts, and let's create a new script called Game Over. The words no one wants to hear. All right, so in the Game Over script, a couple things that we want to do. We want to stop the game. So let's remove this function here, and we don't need this system collections.generic namespace. So we want to stop the game. So stop the game. And this is going to take the score. This is the function that's going to subscribe to the event. We want to restart the level. So let's do public void restart level. And we're going to be calling this from the inspector. That's why they are public. We're also going to want to submit the score to the LootLocker leaderboard. which we can do public void submit score. And we're also going to want a function called public void add XP, and this is for the progression later on. And we're going to take in the score. All right, so let's do the stop game. So if you have stuff going on in your scene, you can actually pause the game by doing time.timescale equals 0. That's one way how to pause the physics of the game. This affects the time delta time. So if you put it at 0, it freezes time delta time. If you put it at 0.5, everything goes at half the speed. So if you want, you can stop the game if you have stuff going on. But since we disabled the player once we did the game over, we don't need that. Now we want to set the game over canvas active. So let's do a serialized field and let's take in a private game object game over canvas. And we're going to set this active so that the game over UI shows. So we can do game over canvas dot set active equals to true. And here we're going to want to get the LootLocker leaderboard and put in that score value. So to do that, let's make a very simple UI for our game over screen. And when I say simple, I mean very simple. So we can right click and create a UI canvas here. You can call this the game over canvas. Make sure your event system here is replaced with the new input system because it uses the old one if you don't press that button and may throw some errors. Now with this game over canvas, let's put the canvas scaler to scale with screen size. And for the resolution, let's put 1080 by 1920, which is a 9:16 aspect ratio. And so this scales the canvas with the size of the screen proportionally. So if you increase the size of the screen, the canvas will increase as well. So now let's add a UI text here. And we're going to want to import text mesh pro. So we want to add a text mesh pro text because the normal Unity text sucks. It's really bad. To get it working is a mess. Text mesh pro fixes that. And I don't know why Unity doesn't have this directly integrated with the editor yet, but who knows? But anyways, now we can click the text here and let's just put game over. Game over. You have lost. Okay, so we have our canvas here. Now let's increase the font size because it's way too small. We want the player to know that they have utterly failed. I'm just kidding. And now we can set the alignment to the middle. And what we can do is click here in the rect transform and set the anchor of the UI to wherever we want to anchor it. So anchoring means that as we increase the size of the screen, it will keep the relative position. So we want to anchor it to the top. We want to put it up here. And so we can select this one up here. This is the top. And we can also press Shift to set the pivot and Alt. So Alt will set the position, which we want. So we press Alt. You'll see we set the position, but we also want to pivot it there. So press Shift and Alt at the same time. And so that will make it scale correctly. And then you can just drag it to wherever you want. And now I like to add a right-click UI panel. And we can set the color a little gray here. And the panel, let's make it the topmost element so that it doesn't cover the game over here, which you can also make bold to really highlight the fact. And now we want to have like a little leaderboard section here. So I'm going to copy and paste the game over script and put score. And let's anchor that to the middle and also set the position, Shift Alt middle. I don't want to make this bold. And let's just do score. And actually let's put the position on the left middle. So right around here. So it's going to be the scores, the top 10 scores. And we can duplicate that, Control D if you select it. And then we can name this one name. So we have the score and the name associated with that person that has the score. So we're going to display those values there. Now we can Control D again on the score. And this is where these scores are actually going to go. I'm just going to put a little dash there so we can get a better angle here. And now we can set the width of the score and also the height. So increase the height so that we can put these scores here. And you can just play around with these values. You can call this score section. Control D, move it to the side. And we can call this one name section. And remember to update the pivot for these so we can press Shift and pivot the name section and the name to the middle right. Okay. And now let's create a button. So UI button text mesh pro, and we can do this, the restart button. We can put this all the way at the bottom, expand it under the text. We can do play again. And the restart button, let's make it much, much bigger. So let's put the scale to 6.6 here, and we can pivot and change the position, Shift Alt to the bottom and kind of move it a little bit up. And once again, just adjust these values as needed. And so this is great, but we need a way to let the players submit their name to be updated in the leaderboard. And so you can do this by right-clicking and clicking UI input field with Text Mesh Pro. And we can call this name input field, and we can just make this much bigger, 5, 5 on the scale X and Y. And we can, in the rect transform, press Shift Alt and put the top middle. And then we can kind of put the height so that it's under the GameOver. And this will be where the player enters their name. So in the text area, under the placeholder, if you expand the children, instead of enter text, we can put enter name, ... And so the player will enter their name here, and then they have to press enter to submit their name to the leaderboard. So we can add another UI button. So Text Mesh Pro button, and we can call this submit name to leaderboard, right? And we can just position this wherever you want. I'm going to make this much bigger. And instead of the button text, I'm just going to put like an arrow. And for the button, I'm going to decrease the width. So it's kind of like a submit button here. I'm going to put this next to the Game Over section, and we'll pivot it to the top right. And you can just adjust these as necessary. And the last thing that we want is a score. So we want the player to know their score, obviously. So the Game Over text, which is the first one, I'm just going to rename it Game Over text. I'm going to duplicate it, Control D, call this score text. I'm going to move it a little bit down, and then this is going to be the score of the player. All right, so, this isn't the best UI design, obviously. This is just to get the functionality in place, and you can adjust it to your needs as necessary. But now that we have this UI in place, we actually need to populate these fields. And so first we need a leaderboard functionality, and for that we will need 8Locker. Now, 8Locker is not a necessity to have a leaderboard. You can program one yourself and have your own server where you keep track of these values. However, setting that up is a pain, and you'll have to program a lot of the functionality yourself. 8Locker provides all of these features for free for you to use in your game, and it's really easy to go and set up. And I'll walk you through all the steps, and you'll see that they are free for 10,000 users a month, which is an insane amount of users. And so we'll be taking advantage of their leaderboard system, their progression system, and their key value pairs, which is like a database where you can store keys and values. Unity has something called player prefs, where you can store player preferences between game sessions, but it's not really safe in the sense that it can be more easily modified. And this isn't a server, so other players won't know about your score. So you still need a server or a database where you keep track of the scores. So let's get started with 8Locker. So for 8Locker, we first need to create an account here, and just put your name, email address, password, etc. and create your free account. I'm not going to go over that. I'm just going to log into my existing account. All right, so now once you're in the dashboard, which is my.lootlocker.io, we need to create a new game. So if you go to My Games here, you'll see we have a new game button, or you can go down to this profile section on the bottom left, click Games, and add a new game. So they also have a sample game that you can check out, but let's set up a new game here. Put the name of your game. I'm just going to put a 3D Infinite Runner. The genre, I'm going to leave it as Action Adventure. We're using Unity, and they use this information to help set up the dashboard. And we are currently prototyping our game. So if we click next, we can actually select the platform that we want this to work on. And they do have a lot of cool platforms here, but for now, we're just gonna stick with the guest login so that we can do it directly in the Unity editor and on desktop. And I'm just gonna click create, but you can select any one of those that you want. All right, so now under your games, you should see the new game that's been created, and you can click it. And now what we wanna do is you'll see that they have some steps here. So first we needed to download the SDK, so we can click download here, and it takes us to their documentation page, which I have a link in the description to the documentation page. And now we can actually go to the Get Started with Unity page here. We can download the 8Locker SDK. Let's go to install the SDK page. And now you'll see that we can install it using a certain number of ways. We can install it using Git, install the entire repo, install from a Git release. I like installing it through Git directly. So Make sure you have Git downloaded on your computer for this to work. So you can just do Git download and download Git for your operating system, whatever that may be, and just go through the installation steps. And so basically, once we copy this URL, we can go to Unity. So Window, Package Manager, then up here, this plus button, we can add package from a Git URL, paste the URL, click add, and now it'll automatically fetch the package from GitHub using Git and download it into your project. Now that we got that done, all right, now we need to set up the OutLootLocker SDK, which the documentation goes step by step on how to configure it. So you can see that if we go to edit and project settings, so we go to edit project settings, and we'll see a OutLootLocker SDK here. We have to paste in these values from our OutLocker dashboard in order for our Unity game to connect to OutLocker. So we need an API key and a domain key, which we can go to settings, game settings, and API in the OutLocker console. So if we go back to OutLocker console, we can go to settings, game settings, and then we can go to API, and you'll see that we have an API key here. So you can copy it, press Control copy. Then we can paste that into the OutLocker SDK. Then we have this API domain. So you can see this is the domain that your game calls to OutLocker, but we need the domain key. So click the domain key and paste the domain key into the project settings here. And now we can keep everything as it is. Press Control S, and we can exit out of the project settings. And now we can start to make use of OutLocker. Alrighty, so now let's go into the OutLocker dashboard, and I'm going to give you just a little overview of the dashboard so you can kind of get a hang of it and know where things are. So here you have the settings where you can change, the platforms that are supported. Right now, we're going to be using this guest login. So for OutLocker, the player has to log in, and not necessarily log in the sense of putting a username and password, but just becoming a user. But as they play the game, they are logged into OutLocker and given a unique ID, and that ID is used to give them XP or get their progression status. So for now, we're going to be using guest login, and we want to enable this and click save. And stage just means this is the testing stage, and live means the live game. So we're going to be doing everything on the stage platform. Next, you can set different character classes like wizard, rogue, paladin, and we won't be going over this, but you can add new character classes. You'll see that you have character classes, and then you can reference these in Unity. Context. So in OutLocker, you have something called assets, which we'll be going over in a minute. You have events that you can invoke, have different assets with rarities, assign templates to the assets, and images. So for assets, if we go into content, you'll see we have this assets here, and assets is basically like in Unity, we have our assets. In OutLocker, we can also have assets. So for example, assets can be materials, they can be costumes, they can be weapons. For example, if you have a sword in your game, you would put an asset sword, and then you can reference these in Unity. You can also see we can make DLCs, which is pretty cool, and user generated content, and they also have a moderation tab, which is really cool. So if you go back to these settings and we go to context, you'll see that contexts are categories that you put your assets into. So for example, if we have different weapons, we'd make a weapon context and have all the weapons assets be in that context so we can easily access it. If we go into system, we'll be in this section a lot. We can actually program the different systems within OutLocker like leaderboards, progressions, triggers, which you can click the documentation here and it tells you what they are and how to use it. We can have different missions that the player has to complete, collectibles that they can collect, and heroes, which seems like this is a new feature that they're going to implement soon, which is pretty cool. And so this is the main documentation page. Another page that I'm going to draw your attention to is the game API page. And so this page actually gives you all the calls that you can make with OutLocker. So for example, if we select player here on the left, if we want to get the player name, you can get it with this curl. So if we're using HTTP JavaScript, we can get it from this API with our API key, and it returns that. And we don't want this curl get. Instead, we're going to want to use this function as an example, get player name function, and it will return an object with a name that we can use. So this is going to be very useful as well. Okay, so for the leaderboards, we can create a new leaderboard. If you go to systems leaderboards, let's create a new leaderboard and let's call this scores. You can select an optional key that you can use to access the leaderboard instead of scores. Just going to keep it as it is. Now we can select the type. So the type is that we want to attach a player name when retrieving scores. You can also use a generic leaderboard if you're not having players. Then we can choose the direction that we want the scores to be returned in. We want it in descending order, meaning that the first score is the highest. Ascending is the opposite. Now we have a couple options here. We want to select enable game API rights. So this allows us to submit scores to the leaderboard via the game API. If you want to be able to overwrite the score of the player, you can select this and it will overwrite their score. However, it will also overwrite it even if the score is worse. So I don't know in this case if we want to do that. Metadata allows you to also submit additional data alongside the score, but we do not need that. So we can click save and now we have our leaderboard and you'll see we have a default player here that was added, which you can actually go to player tab and you can see all the players on your game, which we don't have any players right now. And you have some other options tabs here, which we won't be going over. So now that we connected 8Locker into Unity and we created a leaderboard, now we can access the leaderboard and submit the score. But before we do that, we need to connect the current player to 8Locker first. And to do that, let's just make a new script, right click and create a new script, and let's call this Game Manager. And so if we double click that, open it up, I'm just going to remove these functions and remove systems collections generic. And we're going to also be needing a using 8Locker.requests. So we're going to send a request to 8Locker. Now we can do a start function and we can do 8Locker.startGuestSession. And it takes in a response. If we put in parentheses a response, this is a callback. So once this is called, it will return a response. And with that response, we can do something within this function. So this is a callback notation. And you'll see that there is no 8Locker namespace. And that's because it's 8Locker.SDKManager.startGuestSession. And so make sure you put that or else it won't work. So we start the guest session and really, we don't need to do anything else, but we can just do an if statement here. If our response.success, so if we were successful, if we were not successful, so put the exclamation point at the beginning, then we can just do a debug.log and we can just put error starting 8Locker session. And then we can just return from this function. Otherwise, we can do a debug.log successfully started 8Locker session. And so I'm just going to do it now since we're going to need to do it later. And let's just make our lives less complicated. But we're going to make a main menu screen and we're going to call this function. And we want something to happen after the player is successfully logged in. So what we can do is in the start method, we can actually declare a start method as a coroutine, which is really neat. And we can basically wait until this is finished and then send out an event saying we have connected the player. So we can do a Boolean connected and we can say false. Then if we connected successfully, we can do connected equals true. And now we can do here yield return new wait until. So we can wait until a certain condition has been met. And this is the callback notation as well. So we can wait until a certain condition has been met. And here is the notation for this. So we put a parentheses and we can say the condition that we want. So connected. And this basically waits until this condition is true. Now, once this condition is true, we're going to want to invoke an event. So we can do a serialized field. We can do a private Unity event and we can call this player connected. And so of course for this, we're going to want to do the using Unity engine.events namespace. And once we have connected successfully, we can do player connected.invoke. And we won't be needing this right now, but it's good just to have this set up. So, all right, so let's add this game manager to our scene. So we can right click and create an empty game object called game manager. And we can just drag in our game manager there or add the component. All right, and now once we actually have the player connected, we can call the leaderboard. So if we go to our GameOver screen now, we can access the 8Locker SDK. So we can do using 8Locker.requests, right? We're going to want to submit the score to the leaderboard, and this is all asynchronous. And so this is a call to their API. And so we have to wait for it to complete until we can display the score in the leaderboard correctly. So coroutines are honestly one of the best ways to go with this. So we're going to be making another coroutine, which we can do private, i.e. numerator, and call this submit score to leaderboard. And from submit score, we can call start coroutine, submit score to leaderboard, and we can pass in our score, which we can do here int score, as well as here int, or to actually simplify our lives, not do this, we can do a private int score equals 0. And then here, when we stop the game, we can set the score, which we can do by this dot score. So this references this script's score, and we can equal that to the function's score. So this is just to stop any confusion on which score we're referring to. And now once we stop the game, we can submit the score to this leaderboard, and then it calls this one, and then it calls this function, and now we can submit the score. Now, if you remember, we have the name that the player can submit their name. Now you might want to do this another way, like having the player set the name at the beginning of the game. But in this case, just to simplify, we're going to do it every time that they have lost the game, similar to the original arcade games. So first we need to set the name of the player, and we can do that by doing {LootLocker SDK Manager, and we can do .set player name. It's pretty simple. And now we can set the name of the player, which we need a reference to. So if we scroll up, we can get a reference to that, which if you remember is an input field. However, it's not a normal input field, it's a TextMesh Pro input field, which we have to put using TM Pro to access. And now we can do a serialized field and put private TMP input field, and we can just call this input field. And this is the TextMesh Pro input field, and we can access whatever value we've written there. And if we scroll down for the set player name, we can do input field dot text. So this returns what we've written in the input field. And now this will return a response. And with that response, we will execute this function within this function. So once again, if the response is successful, if we are successful, then we can just debug.log, successfully set the player name, And now if it's not successful, else, we can do a debug.log, and we can do right here, was not able to add the player name. And so we want to wait until this is completed before submitting our score. So we can do it similar to how we did before, a Boolean, and we can just call this name set equals false. And if we are successful, we can do name set equals to true, and we can do a yield return new, wait until a certain condition has been met. In this case, it's the name set Boolean is true. So if we successfully set the player name, then we can do something. And small thing you might notice is that if we never actually set the name of this player, this coroutine will just keep on waiting forever. So if you did want to, instead of setting it equals to false, we can set it equals to true and do name set equals false. And instead of name set equals to true, we have to wait until name set does not equal null. And as before, we can make this a nullable Boolean. And so we can do name set dot has value as our condition to be met. And we can set this equal to null, so it cannot throw that error. All right, and now we have to check if the name has been set. So if the name has not been set, name set, and since this is a nullable, we have to get the value of this. Then we want to do yield break, and this will exit out of the coroutine. Alrighty, so now we can actually add the score to the leaderboard. We can do that with {LootLocker SDK Manager .submit score, and you'll see that if we hover over it, we can put in the member ID, the score, the leaderboard ID, and this returns the callback. So we need an access to the leaderboard ID, which we can just go up here and put private int leaderboard ID. And if we go to our {LootLocker here in the dashboard under systems leaderboard, for some reason the leaderboard I created didn't stick, which is sad. So I'm just going to make one again here. You'll see that the ID is right here, 3725. And before I had said this was a player, but I got confused. This is the leaderboard ID. Since this is such a long video, my brain is just fuming at some points. So now that we have the leaderboard ID, we can insert it there. And one other thing that I want to add is a private int leaderboard top count. So this is how many scores we want to display on the leaderboard. We want to display the top 10 scores on the leaderboard. And now if we scroll all the way down, for the submit score, the first parameter, we can just kind of leave it blank. The second one, we can pass in the score. The third parameter, we can pass in the leaderboard ID. And now this returns a response, which we can check it. And I'm just going to copy this right here. If response success, because I don't want to keep typing it over and over again. So if the response is successful, then we successfully submitted the score to the leaderboard. And I'm just going to copy that, paste it here. And instead of successfully, we can put unsuccessfully. And now that we actually submitted the score to the leaderboard, we want to update the UI to display the scores, the updated scores. So instead of the name set here, let's make another Boolean. So Boolean score submitted, equal that to null. And then here we can just set score submitted to true, else score submitted to false. And then we can do a yield return, wait until score submitted has a value. We can just copy this. If score submitted value, if it doesn't have a value, then exit the coroutine. And now that we did that, now we can call get leaderboard. So this get leaderboard will actually get the contents of the leaderboard and we can display it. So let's make a function for that since we'll call it in multiple places. And we can do a private void get leaderboard. And this one's simple. We can do LootLocker SDK manager dot get score list. We can pass in the ID of our leaderboard and we can pass in how much we want to get. So that's the leaderboard top count and it will return the top 10 scores in the leaderboard. And so this returns a response, which this will have our items that we want. And now we can check if the response is successful. Now we can do something else. We can do debug.log, failed to get scores from the leaderboard. And similarly, I'm just going to copy that and put it here. And instead of failed, we can put successfully retrieved the scores from the leaderboard. Okay, and now we can get these scores and populate the UI. So let's get a reference to our UI scores that we want to populate. So we go up, we can do a serialized field. And if you remember, it's a text mesh pro u GUI. And this is the text. So we can do leaderboard score text. And we also have a text mesh pro u GUI leaderboard name text. So we have to upload the name and the score. Okay, so now if we go back down, now that we got the scores, we can populate the fields. So to do that, I'm just going to use strings and do a for loop over all of the scores. And then we're going to put each score on a new line and then update the UI. So we can do a string leaderboard name, and we're just going to put an empty string. And then we want the leaderboard score with an empty string. And now we can get the items from our response by doing response.items, and this returns the items. And we're going to equal this to a LootLocker leaderboard member array. We're going to call this members. And so you'll see that the members are the players and we can access their scores. So we can do a for loop for int I equals 0. I is less than members.length, which should be 10, which is the leaderboard top count that we passed in. We can do ++ I. And now we can get their name and their details if they have one. So one thing I like to check just in case is if the player exists. So I had an error with this previously, and I just, for sanity's sake, do a if members at I.player equals null. Then let's just continue to the next item in the for loop. Now we can get the name. So if we have a name, members at I.player.name does not equal empty. So if this isn't an empty string, then let's add it to the leaderboard name. So we're going to use string concatenation. Concatenation. Oh my God. Whatever. You get the point. Concatenation. We're going to add strings together. English. Why? We can do members at i.players.name. And then we want to add a carriage return, which basically puts the next thing on a new line. Else, if we don't have a name associated with our player, we can do leaderboard name plus equals members at i.player.id. So we can just get the ID of the player instead. And you'll see we're accessing this members.player rather frequently. So if you select it, press Ctrl D 6 times, and we're just going to call this player. And in the for loop, I'm just going to set the player, which is a LootLocker player equals to members at i.player. So we can avoid referencing it a million times. And now that we set the name, we actually need to set the score. So leaderboard score plus equals, we can get the members at I. Unfortunately, we can't get it from the player variable, but we can do members at I.score. And now let's add in that carriage return. And now after we've done that for loop, we can set the text of the leaderboard name text.setText. We can use that function, and we can set it to the leaderboard name that we computed, and same with the leaderboard score text.setText, set text, and we can set that to our leaderboard score that we did in the for loop. All right, that was a lot of information. So take your time in writing it down and understanding it. And so now that you have that done, we can go back to Unity and let it compile for 3 years as per usual. It's actually gotten much better in the 2021.3 versions, at least. But if we go to the player now, we have this GameOver and score update event, and let's add our GameOver script somewhere. So we can add that and create a new empty game object and call this GameOver manager. And then we can just add our GameOver script here. And let's assign the values of the canvas. So the GameOver canvas, we can just drag it here. The input field, we can drag it there. The leaderboard score text, we called the score section. And then we have to put in the name section here. All right, so then in the player, in the GameOver event, let's add a new event, and let's drag in our GameOver manager and call this GameOver stop game. However, you'll see that a 0 pops up, and this is an error I didn't notice. I was like, why isn't my value in the event getting transferred? And there's a little trick. You'll see that you have the stop game here. However, this is if you want to put in the value manually in the inspector, you have to put in dynamic int up here, stop game. And so this will actually pass the value that you put in the code through the event. So you have to make sure it's dynamic. All right, and so now basically when the player types in their name, we want it to submit the score over. So if we remember, we have the button called submit name to leaderboard button, and on click, we can drag in our GameOver manager and call our function called submit score, which will update the leaderboard. And another quick thing that we can do is in the GameOver manager, let's just put in the restart game function here, which for that we need to reload the scene. And to reload the scene, we need to put a using Unity engine.scene management namespace. And now if we scroll all the way down, we can do public void reload scene. And then you can do scene manager.load scene. You can do scene manager.get active scene. So we're just refreshing the current scene so it starts the level over again, and you need to pass in the index of the current scene, and we can do that by getting the active scene, so getting the current scene and doing build index, and that will pass in the index into the load scene. And if we go back to Unity, in the play again button, restart button, on click, we can pass in our GameOver manager here and call GameOver restart scene. And it seems that I already had a function called restart level, and for some reason I just forgot. Yeah, so let's just remove that restart level function since we don't need it. All right, and then last thing we want to do is update this score here when the game is over, right? So we need a reference to that input, so we can do serialized field, or not input, but the text mesh pro UGUI score text. And now when we stop the game and set the score, we can do score text dot text equals score to string. So since it's an integer, we need to cast it to a string in order for it to display properly. And so now I know there's a lot of steps, you know, but trust me, this is going to be really cool. If we go to the GameOver script here under the score text, we can just pass in the score there and it'll update the score when we do GameOver. And so let's disable this canvas, the GameOver canvas, and we want also the score to be displayed on the screen when we're playing the game. So for that, we can make a new canvas. So right click UI, a new canvas. This can just be the main canvas. And again, we want to scale with screen size with a resolution 1080 by 1920. Let's add in a UI text here. So text mesh pro, and let's call this score. And we can just replace this with score. We can increase the width, make the font bigger, center it, and then in the rect transform, click Shift Alt to anchor it and change the position to the top and kind of put it a little bit down. And so now we want to display the score on the screen while the player is playing the game as so. And so for this score to be updated on every frame, the player will send out this score update event. And now let's make a script here on this score that automatically sets this score text on every frame. So let's create a script. We can call this score updater. And here we can just remove these two functions and the using system.collections. And we're going to want to use using TM Pro here. And similar to the GameOver, we can just copy the text mesh pro uGUI serialized field. We can call this score text. And we can do public void update score. And this takes a integer of score. And then we can set the score text.text equals to score. And this is an integer, so we have to typecast it to a string. So we do .toString. And now, if we go to the Unity inspector under the player, if we add a score update event section here and we pass in our score, we can call the function if we actually attach the script to it. So in the score, we can attach the score updater script, and you can just pass in the text mesh pro, or you can use get component if that works better too. Back in the player, in the score update event, we can go score updater, update score, and remember to click the dynamic int here. Okay, now if we press play, you'll see that the score is being updated properly. Now if we do game over, you see the player disappears, and we probably want this canvas to disappear with the score so it doesn't display it. And we also want to make sure to update the score here, but you'll see that right now we don't have any scores here. And this is because this hasn't updated properly. But if we put our name, or my name in this case, Sam, and you'll see that we press enter, some messages will pop up and it'll basically tell you if the response failed or didn't fail. So in our case, it failed because the leaderboard does not exist. So the ID that I put isn't correct. So let's fix that. And let's also fix this. So in the GameOver script, we can copy the score updater and set it right here to get access to the score text that we want to update. Then in the stop game, we can do score text.text equals score dot toString. For the submit score, we only want to submit the score when we press the button to submit it. So this is not correct here. Instead, here we want to get the leaderboard and display it, right? And let's make sure our leaderboard ID matches properly. So the leaderboard, we have the leaderboard here, 3725, 3725. All right. So I think that was the error that I was getting, was that I accidentally put submit score here. So once we call game over, we also want to set the score in the previous scene that while we're playing the game to false, so we don't see it anymore. And we can easily do that since we already have the event set up. So in the player here, under the game over event, we can add another event, pass in our canvas, and set the game object enabled, set active right here to false. So that's false right now. So it'll remove it. Adversely, we can also do that with the other canvas instead of doing it through code. So you can also do it with the game over canvas and set it to true here. So game object set active, and we can set it to true. And that means that in our game over script where we're doing game over canvas, we don't need a reference to it anymore, since we're doing it directly with the Unity event when the game is over. Awesome. All right, and now in the GameOver manager, we have to put in that score text that we want to be updated when the game is over. So you can just drag that score from the GameOver canvas there. Alrighty, so now if we click play and we mess up or have the character fail, you'll see that the score isn't updating, and in the console, you'll see that we're getting an error. It says bad request, the leaderboard does not exist, which is interesting. And I also noticed that I accidentally assigned the score text in the wrong field. So I assigned this score instead of assigning the score text. So I can just drag that score text into the GameOver script. And so after a bit of debugging, I realized in the leaderboard section, the reason why it can't find this leaderboard is because currently in our settings, we set our application to be in stage mode, not live. And so it's currently live. So make sure you're on stage mode in 8Locker, and you'll see that the leaderboard actually has a different ID. And that's why it can't recognize that our leaderboard exists, because it's using the live leaderboard while we're actually in the staging. So if you go back to the GameOver script, just make sure to update your leaderboard with the correct number. Alrighty, and I'll just make sure to disable the GameOver canvas so we can't see it anymore. And now if we click play and we just kind of stop the game, now you'll see that we have our GameOver here with the score. However, we don't have any scores here yet because we haven't inputted our name. So if we input our name, you'll see that now it'll show our name with the score. And if you update your name and you press enter, it'll update it automatically, which is pretty cool. All right, so that's basically the leaderboard functionality and the score functionality. The only issue I saw is that because we didn't set a name when we submitted a score in this submit score to leaderboard, this function to submit a score actually doesn't run because we set a yield break if we didn't set a name. So if you'd like, you can actually comment that out and it will submit the score and instead use the user's ID as an identification instead of the name. Okay, so now before implementing the experience points and progression in 8Locker, let's first add a little bit more difficulty to this game by increasing the player speed over time and maybe adding more obstacles. So I'm just going to exit out of these for now, and I'm going to open the tile spawner script, and I'm going to go all the way down to where we spawn the obstacles. I find that 0.2 is much too low. Maybe if you put 0.4 or 0.3, it might be a better value. And you can of course mess around with this. And now in the player controller, let's increase the speed of the player over time. So we're going to want to do that in the update function. So if you scroll all the way down to update right here, on every frame, let's increase the speed over time. So we can do that after these calculations. And let's do an if statement. First, we want to check if we're not already at the maximum speed. So if our player speed is less than the maximum player speed, then let's increase it over time. Player speed plus equals time.delta time times the player speed increase rate. Now you'll notice when we increase the player speed over time, the jumping will also stay in the air for a longer time. Since we're going faster, the jump is more elongated. Let me show you what I mean. So right now, if we are starting with an initial player speed of 4, you'll see this player speed here, and we jump. The jump is pretty high, but if we make the speed really high, you'll see that the player kind of flies away for a long time. So the way we can get around that is by increasing the gravity so that the gravity makes the player fall down faster as the speed increases. So gravity and the player speed will increase proportionally. So to do that, we can just do gravity equals, and there's a couple ways how to do this. I found that I can just do this initial gravity value minus the speed of the player. So the initial gravity value is negative 9.81, and then we just subtract the speed of the player, and that will be proportional. So for example, if we now increase the player initial speed to, let's say 10, and we press play, you'll see that now the gravity will increase and it'll fall down at a faster rate. And I'm going to just set that back to 4. Now, another important thing that we need to take into account when increasing the speed is the sliding. So right now, if we slide, it's not very noticeable with a lower speed. But let's say we increase the speed. This is hard. Let's say we increase the speed here, and then if we slide, you'll see the sliding animation takes a really long time. And this is because currently our sliding animation waits until the clip has finished playing. So we have to make our animation faster the faster that we go. So the speed of the animation has to be faster. In this case, we can change the speed of the animator itself as time goes on. So if we go in the update function, right where we were previously, let's change the speed of the animator to correlate with the player's speed. So first of all, let's do an if statement. If the animator.speed is less than a certain amount, now I found 1.25 to be a good value. If it's over 1.25, it just looks way too fast and it doesn't look like it's sliding at all, but you can mess around with it. And now let's increase the speed of this animator over time, and this will increase the speed of the animations that it's playing as well. And so basically, as the speed of the player goes up, we want to add the value to the animator speed. But we don't want this to be a huge value because, as you see, 1.25 is already too fast. So instead of just putting the player speed directly, one calculation I found that works is 1 over the player speed. And so this is the inverse of the player speed. So adding the inverse over time. So over time means times time.delta time. And every frame we add the inverse of the player speed to the animator speed. And this will increase the animation over time. And so then we have to now update in the slide coroutine. We have to update this wait for seconds slide animation clip, and we have to take into account the animator speed. So as the animator speed goes up, we want this wait for seconds to go down, right? As it's faster, the amount of time that we're waiting for it to complete lessens. And so this is the inverse, right? As one goes up, the other one needs to go down. So for the inverse, instead of multiplying, we divided by the current animator speed. And so now we only have to wait until this animation has been completed, divided by the speed of the animator. And as you click play now, and we go to our player and you kind of increase the speed a lot, you'll see that the sliding stays pretty proportional. Oh, so let's increase the player speed here to 25. It's gonna be really fast. And now if we slide, you'll see that it looks pretty normal. Seems to work well. And the jumping is pretty accurate. And again, you can play around with those values and see what works best. And so that's the basics of the player controller. The only thing I want to mention is that if you go faster, the Cinemachine virtual camera damping might lag behind as you turn around super fast. So you might also want to adjust the damp of the Cinemachine virtual camera if you notice that over time, as the speed increases, it does lag behind. All right, and finally, the last thing on this video is to add in progression and unlockables into our game. And to do that, first we need in 8Lootlocker to implement what we want to be unlocked. So in this case, usually for this kind of games, you'd unlock a character, or maybe you'd unlock some sort of special ability over time. So if you go to the 8Lootlocker dashboard, under systems, you can go to progression. And now we can add new levels of progression. So if we add a new level here, we can determine how much XP is required to reach that level. So currently level 0 is the default level, and we don't want to reward the player for being at the default level. So we'll just add a new level called level 1, and let's put this XP threshold to be maybe 1,000. Let's add another level. Let's do 2,000, and the last level we can do 3,000. There's also a grants all reward. So if you have multiple rewards, you can grant all of them at once if you check this. If not, it'll just pick a random one. And there's also prestige levels if you need that functionality. And so now for rewards, what we can do is attach a reward to this level. If we click add reward, you'll see that it brings up the asset menu, and we don't have any assets. So we can go into content assets and create a new asset. And you'll see that we have something called the context here. And before we create the asset, let's create a context for these assets to live in. And this is just to group assets together so that we can easily access them. So if we add a new context, we can name this skin unlockables. You'll see there are some other fields here which you can hover over this eye and it'll tell you what it means. So how complex you want this to be, if there's a character class, if this should be shown on Steam, and maybe something that this asset depends on. And now you have to be sure to click save context. And now if we go to context assets and create a new asset, you'll see that under context, we can now select unlockables. And for the name, we can just give this any name you want. For example, if you're unlocking a certain skin and this player is called Rachel, then you can put Rachel skin. In this case, we're gonna unlock a color for the character to color their capsule mesh. So let's create different colors. So we have a green color, and be sure to click save. So for this basic information, you'll see we have the name, the ID of the asset, how much it costs on a discount, if this is a unique instance, if the player can only have one of these assets, if they can purchase it, if it's a featured asset, or if you want everyone to own this asset at a certain period of time. You can also implement rarity. You can also have variations, similar to have materials in Unity have different variations. Let's say you have a skin that has different colors. Well, you can add different variations, have a main skin asset, and then have a variation where you can put in the color that you want or add the material to the path of the material in Unity. And then once you connect to 8Locker, it'll return the path to you, which you can then use to load the resource appropriately. You can also have different platform properties, filters, and storage, like key value storage. You can drag files in here as well and load the files through 8Locker. So instead of loading it through Unity, you can drag it here and then fetch the asset from 8Locker and some other fields like the context here. So now that we have this set up, in our case, I'm just going to be using the name of this asset to load the color. And I'm going to show you how to do that. But if we go back to the assets folder, let's add 2 more. So we want a red color under the Unlockables context. I'm going to click save. And then if I go back to assets, I also want a blue color under Unlockables. And I'm also going to click save on that. And now we have 3 assets. However, they're all inactive. So we have to make sure to mark it as active so that we can use it. Make sure to click save and just do that repeatedly for all of the assets. So activate, save, we go back, and let's activate the last one, save. Okay, so we have all of our assets here. Now let's go to our systems and our progression. And silly me, I did not click the save button when adding progressions. So be sure to click the save button when you're doing that. But since I didn't do much work, it's not a big deal. So make sure to add your progressions. Then we can add a reward associated with the progression. So once we reach this threshold, this asset or reward will be unlocked. So let's say we want to grant the green asset at XP threshold 1000. Then we want the blue. And then finally, we want the red. And make sure to click that save all button. That's really important. So now that we have listed those progression items, we can go back to Unity and implement that. But I just want to call attention to, if you go to player, you can see the list of all your players. You can view information about them. And then here under progressions, you'll see that we can give them XP manually from the 8Locker dashboard so that we can easily test it. And under leaderboards, we can also see the different leaderboards with their score in it, along with their files, storage, different orders that they may have bought, and such. And if you want to reset a player, you can always just click GDPR, reset profile. All right, so let's implement that. So to do this, I'm just going to make a new scene with a main menu. I'm going to go to scenes and create a new scene here. And I'm just going to call this the menu scene. Under the main camera, I'm going to click the clear flags to solid color. So we have a solid color. And then you can just select whatever color you want for your background. I'm going to make a new canvas. And then I'm going to put some of UI text here. So a text mesh pro. And let's just call that the title of the game, which you can call that whatever you want. Templex run so I don't get sued. And you can just adjust that to wherever you want. I'm just going to quickly put this together. I'm going to also add a button to start the game. So here we put start. And we can increase the scale of this. Under the text, we can put start game. And so here, when we press this button, we want to start the game under this on click. So we can make a new script here to start the game. So under scripts, we can create a new C# script and we can call it the scene manager. So in the scene manager, we can erase all of this and put using Unity engine.scene management. And so I'm just going to make a function that makes it easy for this to be reused. So we want a public void load scene. And let's make it so that we can pass in the name of the scene name. And so we can do scene manager.load scene. And I did make a mistake here. And let's put in scene name. The mistake is that I accidentally named the class the same after the scene manager. You really don't want to do that. So I'm just going to put game scene manager so it doesn't throw an error. And then back in the Unity editor, let's press F2 to rename our file to Game Scene Manager. Then under Start button, we can add our new component called Game Scene Manager. We can drag it into the on click, and then we can call Game Scene Manager Load Scene. And of course, we need to give our scene a name. So under Build Settings, let's actually add our scenes here. So this is called Menu. And then the other scene is called Sample Scene. So you can press F2 and rename that to Game. We want to make sure to go to File, Build Settings, and add this open scene as well into our build settings so that it can correctly go between the scenes. And if we go back to the menu, then we can input the name of the scene we want to go to, which is called Game. And now here we can make another page to select the skin of the character, but for simplicity's sake, I'm just going to put it right here in the main menu because this video is already super long. So we want to have the player be able to choose their skin. So to do that, we want to load in all of the skins that are available. So let's create a script to do that. So to do that, we actually have to instantiate the LootLocker instance in the main menu. And once you do that, it'll actually create a singleton that will persist between the different scenes since it uses do not destroy on load. So similar to how we did in the other scene, we can have the game manager here, game manager, and you'll see that this is just the script that we made where we connected to the LootLocker guest session. And so once the player is connected, we want to fetch these items. And actually we want to add here, when the player is connected, they can be able to press the start button. So while they aren't connected, we can set the start button to not be interactable. And once they start, we can drag that into there and then put button interactable here, check mark it. So now once the LootLocker instance has been loaded, only then can we start the game. If not, then the functionalities won't work correctly. And now let's load up the materials. So let's create a new file, create C# script, and let's call it player skins. And if you click that, now we can re-race this functions and the system.collections, and we want to be using lootlocker.requests. So now we want to make a function that's called when the LootLocker instance is instantiated. So we can do private void get skins and do LootLocker SDK manager dot get inventory. So inventory is the inventory of the player. And when we unlock an item, this will be available in our inventory. And so here we can get a list of all of our unlocked items and display them. Now, if you want to know exactly when the player has received a new item, I'm not going to go over that in this video, but there is something called player asset notifications, which is a call you can make that is called when assets have been granted or given to the player since the last time the endpoint was called. All right, so here we can do if response is success. Then we can do debug.log and say successfully got the player inventory. Else we can do a debug.log and we can actually just copy this right here, put it here, and we can put unsuccessfully or failed to get. So here we can get our inventory with response.inventory. And this returns a LootLocker inventory array. We can call this items. So this is a list of all of our items. And now we can do a for loop for them. So for int I equals 0, I is less than items.length plus I. Now we can access the skin. And now the good thing about context is that here we can filter out the different contexts. So for example, we can only do this if this is in a specific context. So if the items at I.asset, the asset associated with this item, if the context equals, and in this case, we called it Unlockables. If you remember here, we called it Unlockables or whatever you named it. Then we can actually add it to our list. So since we don't know exactly how many items the player has unlocked, this is going to be a lot of items and it's going to be hard to fit it in the screen. Luckily, we can use a scroll view to scroll through the different materials or items the player has unlocked. So under the canvas, we can add a new scroll view. You can right click and go to UI and add a scroll view. We can call this skins scroll view. And you can position it to the bottom and also pivot it. And I'm just gonna put it a little bit higher on this list. And then you can increase the width to however long you want it to be. And so let's say in this case, we want it to be a horizontal scrolling like many other games do. Well, if you expand it, you'll see that we have some items here under this scroll rect, where it says vertical scroll bar, you can delete it so it doesn't show up. And then you can disable it or just remove it entirely from the child. And so the way it works is that to add items to the scroll view, you'll see that we have the content here. Basically, we want to add our items as children to this context. So let's say we want to display the color of the skin in this case, or you might want to display the image of your 3D model. Well, we can add a new UI here of type image, and then we can move it around to be kind of centered here. And so let's say this is the image of our skin. If we control duplicate that, control D, you'll see that they're at the same position, but we want the images to be one after the other as so 1, 2, 3. So one way we can do that, and this is a pretty neat thing you can do in the content, and we can add a horizontal layout group. So this will position elements horizontally, and you can add in how much spacing you want them to have. So for example, you can decrease the spacing, you can put the alignment that you want them to have, and some extra settings like padding. But now you'll see that if we keep on adding things, everything will try to fit in this little square, and we want to be able to scroll through the different items, right? Well, under content, additionally, you can also add a content size fitter with the horizontal to be unconstrained, since we want them to scroll horizontally, and vertically, we don't want them to scroll, so we can just put the preferred size. So now you see we have the items here. And if we keep adding items, you'll see that if we increase the spacing between them, now they'll be spaced more. And now we can test it out. Before we can click play, make sure to go to the standalone input module in the event system and replace it with the input system, the new one, so that we can actually interact with the UI. And you'll see that now we have these things here that we can scroll. You see that we can still scroll downwards even though we're not supposed to. So in the scroll rect, just make sure to unselect vertical here so we can't scroll vertically, only horizontally. And of course, make sure to do this while you aren't in play mode or else the changes won't be saved. Okay, so cool. We have these images here and we can just delete all of them except for this one. For the content, I'm going to add a top padding here so it's kind of in the center. And this is going to be where we want our image to be placed. So how can we color this based on a name? So let's say we're pulling in the information from LootLocker. It's going to give us green, blue, and red. How do we make this image green, blue, or red depending on a string? We can make a script for that. So let's make a script. Right click, create a new C# script, and let's call it player skin item. And we're going to attach this player skin item script to our image, which we're going to be making a prefab of. And let's edit that script. Let's comment this out. We can remove the systems.collection. And so what we're going to want to do is in our player skin script, once we verify that this is a player skin, we're going to want to instantiate the prefab under the content game object transform. So to do that, we need the serialized field, private transform scroll view content, and we're going to spawn our prefab under there. So we also need a prefab, which we're going to make right now. But we're going to do a private game object prefab. And we can do something like game object item equals instantiate our prefab. And we can instantiate it under something. So we can put the scroll view content. And I'm just going to rename that to scroll view content transform here. So we instantiate the prefab, but now we need to set the color of it. So under the player skin item, let's make a function to set the color. So we can do public void set color, and we can pass in the string of the color here. And now we can call item.getComponent player skin item, and we can call set color. And we can pass in the color of our item, which in this case, we can do it by getting items at i.asset.name. So this returns the name of the asset, which we're going to use to set the color. And now we need to set the parent of this to be the scroll view content transform. All right, so now we set the color of our game object. Now we have to go here and implement that. So to do that, we can do something pretty easy. There's a function here that we can call called color utility from Unity. And we can do try parse HTML string, put in the color, and then it will output the color that we put in as a string into an actual color variable. So out color color, or in this case, let's just call it new color. And now we can get the component, which is an image, and set the color of that to our new color. And to access image, we need to import the using Unity engine.ui namespace. And so this is great. Let's put that in our item. So under this image item, which I'm just going to rename to skin, we can make this a prefab. So go to assets. Let's just make a new folder called prefabs. We can paste in our skin prefab and delete that from our list. And then we need to add in our new script. So let's just add in our player skin script here. Let's put in the content to the scroll view content transform. Let's insert our prefab. And basically we want to wait until the player is connected before calling this function called getSkins. So if we put in our player skins here in the game manager player connected callback, we can do player skins. And then small mistake, I made it a private function. So make sure that is public so we can access it in the inspector. So now we can do player skins and put get skins. So we can get all the skins. So if we click play and just wait for a little bit, you'll see that we successfully got the player inventory, but for some reason it's not adding the images. So I think it's not passing this if statement, which is pretty easy. We can just debug our program, which I already installed a Unity debugger here. And if we connect it to our instance of Unity by pressing play and put a breakpoint where we want, then we can click play. And you'll see that now when we click play, it will successfully get the inventory, but you see that there's nothing there. And that's because the player actually doesn't have any XP, which you can go back to the {LootLocker} dashboard, and under our player, we can click view and progression. You'll see that they don't have any XP. So let's just give them the maximum XP here and click add XP once you put 3000 there. And if need be, you can just reset the XP here. Alrighty, and now we actually need to add XP to the player. So when the game is over, their score needs to be added into their experience points so that they can later unlock these skins. So to do that, we can just go to our previously created public void add XP int score. And if you don't have this created, you can just do that now. And so to do that, we use the {LootLocker SDK as per usual. So we can do {LootLocker SDK manager .submit XP, submit experience points, and then we can pass in our score, and then we get back a response, which we will then use this callback notation as per usual. And then we can do if response is successful, then we can debug.log successfully added XP. Else we can do debug.log and put here failed to add XP. Now we can call this add XP function. If we scroll all the way up into our stop game function, we can do this before or after getting the leaderboard, but we can just do add XP and call that function there. And then put in our score. So now our score will be updated in {LootLocker}. And once we click play and we wait a little bit, you'll see that now all the 3 images load. Awesome. And that's what we have unlocked. Okay, so now that we have that loading in, now let's actually assign it to our player once we click on it. So how can we do that? That is a great question. So if we go to our player skin item, you'll see that this is attached to our game object with the image. And basically we want the player to be able to click on this image. And when they click on it, we want to assign the skin to the player. So to do that in Unity, we can use something called an iPointer click handler, which we need to import the using Unity engine.event systems. So this is an interface that we can implement from Unity that makes it super easy to click on UI, and in response, we can do something. So you can see here, it says an error. We do not implement the interface member on pointer click. So we need to implement that if we extend from this. So a little trick you can do is kind of hover over this in VS Code and click Control dot or Control period and do implement interface. So you want to click it, press Control dot or period and implement interface. Then we can erase this throw new system exception. And basically this will be called whenever we click on our item. So when we click on our item, we want to store this value that we're clicking on that the player can load in. Now you can use the player preferences for this, but then again, you know, the player preferences is more easier to manipulate. So in this case, let's just use 8Locker. So let's import the using 8Locker.requests. Then once we click our item, we can do 8Locker SDK manager dot update or create key value. So key value pair is just you have a key and then you have a value. And so the key is like the ID associated with the actual value of something that we can use to access or set that value. So in this case, let's put a value of skin. Then our value will be the name of our skin. So let's just put in the color name, which we need to declare. And then it returns a response here, response. And if the response is successful, then we can debug.log. And we can put set player skin color successfully, key successfully, else debug.log. I'm just going to put this on a new line and going to copy what we wrote here already. And instead of successfully, put unsuccessfully. And so for the color name, let's just declare it up here. Let's do private string color name. And here, once we set the color, we can do color name equals color. Awesome. So let's try it out real quick. So if we click play here and we set this color here, we go to the console and we click a color, you'll see that we set the player color successfully with a key of skin and a value of green. Alrighty, so now let's actually set the player material to be this color. So if we go into our other scene, so we go into our game scene, we can actually make the game manager disabled since we are now connecting the 8Locker instance in the menu and we don't need to do it in this scene. Then let's just do this in the player controller. So if we right click and edit the player controller, now you'll see the issue with this. If we do it here, it takes a little bit of time for it to fetch that key value pair from 8Locker. So you're going to want to give the player a little time for the material to fetch, or maybe you can do it on the first scene once you click it and then transfer over the value to the game scene. But for now, for simplicity's sake, I'm just going to go over getting that material and changing it on the player. So in the start method, let's call our function to change the player material, which we are gonna wanna make it a coroutine. So let's just do start coroutine. Let's call this change player material, and you'll see why in a second. And so if we do here, private IE numerator, change player material. Now first we have to fetch the player material from the key value pair that we set. So we can do 8Locker SDK manager, which we don't have that imported actually. So make sure we're using 8Locker.requests in this player controller. And now we can do 8Locker SDK manager get single key persistent storage. So this takes in the key, which in our case is skin, and returns a response with our new value. So if response is successful, then we can do debug.log and we can do successfully retrieved player storage with value. And then we can put the value that we want here. In this case, we can access the value with response.payload.value. Else we can do a debug.log, which I'm just going to copy it here, and we can put unsuccessfully and just print that out. So now that we got that, we can store the color somewhere. Right here, we can do string color equals and make it an empty string. And we can set the color here to be response.payload.value. And now we want to wait until this has completed before actually setting the skin of the player. So we can do it as before. We can do a bool with a nullable value and do player skin request and set that to null. And now once we successfully got the player skin, we can do player skin request equals true. Else we can set it to false. So player skin request equals false. And now here we can do a yield return new, wait until something has completed. In this case, we will wait until the player skin request has a value so that it's not null. And then once we have completed this request, we want to change the material of the color. We want to change the player material. So if we were able to get a player skin request successfully, now we can parse the HTML string similar to how we did before and set the player skin. So once again, that's if color utility dot try parse HTML string. We can pass in the color that we parsed and output a color called new color. So now we have to get the mesh of the player, which if you remember is the child of the player, since it makes everything easy. So we can go up and set that in the inspector. You can also do it through the transform. However, I just prefer to do it like this, so it's clear that we are getting the correct object. And we can do a private game object and call this mesh. And so now if we scroll down, 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 back to where we were, we can do mesh.getComponent, mesh renderer. And now we can set the material.color equals to our new color. So here in the player skin request, there's an error. We have to do .value. So if we have a value, so this returns the value of this. And if it's true, it'll be positive. It'll go through this if statement and then it will complete this. And here instead of color, we actually want to put new color, since this doesn't accept a string, but a color. Okay, great. Well, that was a lot. So let's, see if it works. So if we go to the inspector, let's make sure to put in our mesh, right? So you see we have a mesh here. So we expand the player, it's the child, and we can just drag it right there. Now we have the mesh, and you'll see if we click play, it won't work because the 8Locker instance is now in the menu. So let's just click play and test this out. All right, so we have this. Let's say we want player to be red. So now we can start the game, and now you'll see that our player is red. Woo! That is super awesome. So that's the basics of this video, and that's not really basics. There was a lot of information here. This is really fun, actually. And so basically, there's a lot of things that can be added to this, obviously. For example, you'll see that it kind of ends there. The player can see when the next turn has ended. So I recommend adding some post-processing so that you can't actually see past a certain point, so that everything kind of remains mysterious as well. You can add in coins, you can add in actual material unlockables, you can add in a store, advertisements. The possibilities are endless, but I do hope you enjoyed this video because it did take a really long time. I have been doing other stuff in the meanwhile, but this has taken like 3 or 4 months to get set up, record it, and edit it. So make sure to hit that like button, subscribe if you found it useful, and I also have a Patreon that you can subscribe to if you really want to support me and help me continue making these kind of videos. And of course, you get some benefit out of it as well. So thank you so very much for watching. I really hope you enjoyed this video. Once again, thank you to the sponsor of this video, 8Locker, and I hope you all enjoyed the effort that I put into this and that you learned a lot from this. So with that, I'd like to thank all of my patrons for the support. It really makes these videos possible and helps assist me as well. So with that, I'd like to thank my new patrons. In the supporter tier, we have, thank you very much. In the enthusiastic tier, we have Wolf SV, Thibault, Charles, Marco, Chris, Wagner, Medi, Mark, Sam, Lewis, Huying, X Stanzi, Paula, Z, Dor, Mackenzie, Sarge, Taylor, Merda, Chris, Lil Blue Nutta, Hey, Chris, Tarnumius, Jerry, Emre, Jason, Mark, Joshua, Jonghu, Aram, Brendan, Yeonju, Gaetong, Baker Campbell, Kung, Poyan, Max Retro, Cam Yup, Cameron, and Richard. Thank you so much for your support. It is super appreciated. In the dedicated tier, we have Fadi, Cameron, and Schlake. Thank you so much for your support. It is super appreciated. In the loyal tier, we have Mike. Thank you so much for your support. It's super appreciated. And finally, in the learner tier, which this is my first learner tier subscription, and I'm really happy and appreciative, we have Michael Taylor. Thank you so much, everyone, for your support. It is super appreciated. And I've said appreciated a million times, but it really is. And I really hope you enjoy this content. And I really want to keep producing more and more content, and not even tutorials. I want to do all sorts of videos that are more entertaining as well. And also live streaming and topics about myself and my life, for example. So if you do want to see more of that, make sure to comment below, like, subscribe, you know what to do. So thank you so much for watching, and I'll see you next time.